All right, it's been 5 minutes. All right, so where did we leave off? Welcome back to my game engine development stream. Yesterday we did a whole structure change to how we do inspectors, and it wasn't quite finished when we terminated the stream yesterday, but I did wrap up after taking a little break yesterday. I did wrap up that code so that way it was able to compile and run. And there wasn't really much to say on how that went. So now when we want to do an inspector, our custom asset inspector, and this would go for whether you're making a game system, whether you're making a module for games, or if you're using one of the vanilla built-in systems. Basically, you take and create a child class of this class, editor file inspector. It's really simple. It's got an initialization function that takes in the selected files. It's got an onInspector GUI call where you do your GUI code. And it's got an optional destructor and cleanup function that you can implement if you want. When you want to register it, that was the API that we were fixing up yesterday. It's actually as simple as a single line call where you register the class with its extension. And that's done in the case of the textures, where the inspector you see here, where we have the texture type path and other details. That's done with it's done in textures init. I'm trying to find that function real quick. Init, there it is, init textures. So during the initialization of all the other texture related graphics stuff, we make a call to editor register file inspector, and literally just pass in the class as a template argument and the extension we want to associate it with. So this is kind of an interesting way to dependency inject. It's not super complicated. You can pass in the class as the type, and then what it does under the hood is it registers a factory for it. So that way the editor doesn't need to know, or the editor code doesn't need to know anything about texture inspectors, and it can instantiate them. Yeah, and now because we are using the if I go to the implementation, we're using the new polymorphic union type that I had come up with over the weekend, which is located here, polyunion. And where's the current, so these are the registered factories, but, oh, that's in the inspector window itself, where we have a polyunion of file inspectors. Now those can be created and destroyed without allocating any new memory, or at least not allocating any new memory for the class object itself. If the object itself needs to allocate things on the heap, it will, but for simple things like swapping out inspectors that just like have fundamental values stored in them, now when you go to reload, it just takes that same area of memory and supplants it with another object of a different type, and that's how we have the multiple extensions set up now. So previously we just had it hard coded to give this message whenever you selected multiple extensions. Now that is itself a inspector, so the file inspector code gets replaced, and then when it comes time to do the drawing, it's as simple as calling onInspector GUI on that object. And yeah, I like it. I think it's quite a simple solution, and the API is really simple. You just register the class type with a single line, really easy to read. Yeah, I dig it. So there's still more work to do. Now we have it set up such that we can read the contents of a texture file, and it populates in here. You can see that this one's texture 1, nearest none, and this one's texture 2, linear. We can also see multiple selections when we're selecting them both, because we implemented the multi-select flag or the mixed value flag for combo boxes yesterday. But the one thing that we can't do when we go to make these edits are lost immediately. These apply and revert buttons don't do anything yet. So that's what we're going to focus on right now. For a minimum product, this is probably okay. The texture type doesn't do anything yet. We don't support textures beyond 2D textures right now. But this would be the framework in which we would add them, or add support for them. Additionally, while we have planned ahead and decided to do, like we have a whole design that we did a couple of streams ago, where we've decided that we're going to allow for multiple paths for things like texture arrays and for cube maps or sprite sheets or something like that. We currently are only supporting the first. So if I was to make a change to eptext 2 and add a second element in there, these two contain the same first element. The inspector will still consider these two paths fields mixed, but when it goes to load texture 2 for use, it will display texture 1 as the texture, or as the raw image for the texture. So I just saved that change. If I go to texture 2 now, we see that it says text 1. It still says text 1 if I select text1.eptext, but if I control click and select them both, it says multiple values, and that's because they disagree on how many elements there are. Eventually will display all of them inside of a widget that allows us to reorder and edit the paths separately. But for now, it's just going to be the first path that we use. Speaking of reordering, I did actually identify just this morning. This was something I was looking for quite a while. I did just identify this morning a widget that actually implements simple sorting. I'm just trying to find it. Is it in drag and drop? Yeah, here it is. So there's a couple of places in your IM GUI that implement drag and drop, but drag and drop to copy, move, or swap items. That's something that I wasn't really sure how to approach. And this is actually a simple solution. So in here, in this demo, you can see we got 5 items. If I click and drag, it allows me to reorder them. And it's not so complicated. I've taken a look at the code to see how quickly I could use it. And it should be, yeah, right here. The gist is that we are not doing anything until we are not mousing over the selectable while we have it clicked and dragged. So is item active is true while we are holding down the mouse button on the item. But if our mouse leaves the bounds of the item, so if I take and bring the mouse down, then that's the point where a resort should happen. And so what happens is they make the selectable, and then a simple if statement to say, is the item being dragged right now, and is the item being hovered at the same time? Is the item being dragged right now, and has the cursor moved off of it? If it has, then what happens is the direction of the move is determined by checking the direction of the frame's mouse drag delta, which tells you, the X and the Y that your mouse has moved that frame while the mouse has been down. And if if the Y goes negative, we subtract 1 from the element index of the array of items. And then if it's positive, then we add 1. And then after clamping, to make sure that the next index is within bounds of the array, basically just swaps those 2 items. Really simple. I dig it. I probably will do something similar in my case. However, it's not perfect, and I'm able to show to like having spotted how the code works. I can actually just quickly create some problems like right off the bat. So like if I click and drag item 1 to the left, and then like move my mouse around, it'll zip around the list because it's determining what direction it should move by measuring my drag Y. But it like zips down to the bottom and up to the top. Basically, it's only well defined when I'm clicking and dragging straight up and down. If I'm dragging off the bounds, it does weird things. And so this is not a perfect solution. But if and when, like today, after we've gotten serialization figured out, I may come back and implement this just for the sake of being able to just for the sake of having it. I'll have to come up with a more robust solution so that way you can't screw things up by dragging off to the left or whatever. But for now, that's a back burner item, but it's something. It is good news that I found a really simple way to do dragging and dropping, which will be important when we go to reorder the path stuff inside of the inspector. However, title of the stream is YAMLs, or is a texture asset serialization, and that's the most critical step of the inspector for files. Is that you make a change, you want to be able to save that change. So that's the goal for today. Because we have the inspector working so well with the ability to swap in and out, to change states inside of the inspector, we're just going to start with that first element, which is to take the data that we've got that we put inside the field, and when you click apply, I'm kind of getting myself distracted. When you click apply, that will save to the file or the files that you've got selected. We'll also want to implement revert, so that way if you make a change in here, you can roll back the change. Yeah, that's pretty much it. So let's get started. The apply and the revert button are going to be standard for all asset inspectors. So rather than asking each inspector to implement them directly, I'm instead going to take over that part of the UI and then just have a callback inside of the file inspector class that handles when the user's clicked apply or revert. So let's start there. So I'm going to close all of these. I'm going to open up the set a few things back up to the way I like them. All right, we're going to go to, I guess it would be inside of inspector.cpp. Let's take a look. So the way we currently do it is that every frame we will either, like if we have a selected entity, one or more selected entities, we will draw out the entity inspector, which means that we do the transform component, which is hard-coded. Every single entity has a transform on it, and so we just display that in the UI for all the entities we've got selected. And with those selected, with those done, we then move on to any other components that we've registered. And presently, that's handled by basically a registered callback. I'm wondering whether I should change that. My impression is that a callback is still sufficient for the sake of a component inspector, but I'm on the fence about that, because it would mean that we got two different styles of API for two different kinds of inspectors. But I'm going to put that on the back burner. That's not our focus today. When we have a file selected instead, though, we just directly call on inspector GUI. So for us to implement the apply and revert buttons globally, There's a couple of ways we can do it. We could do a header right here. So that is, we could do the IamGUI like image, and then draw like the icon or the preview, and then add the apply and the revert buttons right here. That would be one way to do it. Upon clicking a apply or revert button, though, we need to trigger something inside of the file inspector. So an alternative way to do this would be to, inside of the file inspector itself would have the behavior. I don't, the file inspector itself would have the header. The behavior obviously will in the file inspector. I think it would probably be best to separate that. The header of the inspector, where it displays the file name and the apply button and the preview if it has one, that probably deserves to be separated from the class. It probably deserves to be just done directly in here. So let's do that. I'm gonna do IamGUI. We'll do text, and what we're gonna do is we're just gonna display the file names that we've got selected. Where should we do that? Let's I should be in the habit of launching Unity and Unreal before I start these streams, because I always refer to them. It would make sense if you're selecting a single entity, or a single asset, that you would see the single asset name. If you're selecting multiple, maybe it would make sense to not see that. Maybe it would make sense to see the term multiple selected. I'm not sure. Let's launch a project. And of course, it's going to take forever to open. While it's taking forever to open, I'll do the apply and revert buttons. We'll do button apply. We won't specify a size. Revert, same deal. And then we'll need to do a response inside of the file inspector if these buttons are clicked. So we'll do, if the apply button has been clicked, we'll do current file inspector. And we don't currently have a response callback in here, but I'm going to say on apply. And then we'll do something similar for this guy. We'll say if the revert button has been clicked, and we'll say current file inspector on revert. And then we'll draw the GUI for it. So what this will do is it'll separator. I'll put a little separator afterwards. So what this will do is it'll make an apply and a revert button. If you click one, then it calls on apply or on revert. Simple as it gets. But this does mean that we're going to need to go to file inspector.h, and we're going to need to add this callback. So we have init and on inspector GUI already. Let's do virtual void on apply. And that's also going to be a pure virtual function. We'll add the equals 0 to require this to be overridden. And then we'll do virtual void. I'll just copy this line, and it'll be on revert. And I'll shift F to make sure everything lines up. Cool. All right, so now that we've got on apply and on revert here, we need to implement it in the classes that we have based on this. Those classes are the all-ended inspector. Texture inspector is one. The one that we care about right now, the one we're doing all this work on. But then there's also the multi-extension file inspector, and this is less of a file inspector and more of a GUI for when you have selected multiple files. Oh, hang on, yeah, this is a good edge case, because in the case of the multi-extension file inspector, it doesn't use the apply or revert buttons, does it? I wouldn't expect it to, at least. Gosh, Unity, come on. I think this is all package manager stuff happening inside of Unity every time I go to launch it. Basically, I loaded up a number of things from the asset store. It seems to always get stuck on importing, and can't think of a good reason why I would do that. Anyway, so if we have multiple, well, let's first take a look at the header. If we were to select multiple files, it does 3 objects, and you can narrow down the selection. If the multiple objects you selected are of the same type, it just displays how many and what kind they are, and also what thing you're inspecting. In this case, it says import settings, as opposed to object properties or whatever. But yeah, now I'm gonna have to think about this. I did a custom file inspector for the sake of this kind of API, but it doesn't really make sense to have an apply or revert button there. So how would I control for that? Let's take a look at the inspector again. What do we got inside of the CPP file for this? The CPP file actually is really simple too. At least it's simple right now. We do need to, at some point, obtain the selected files. So that way when you go to click on a filter, it will be able to directly edit the list of selected items. Well, I guess what this means is that I'll need to have a custom API for, or not a custom API. I'll need to hard code this behavior, I guess, is what that means. I thought I was being kind of clever by doing this as something that you slot in, but it seems to me that because I want the header to be implemented in here before we go to the other. And I don't want to be thinking about what kind of object is inside of this before I go to draw this. I'm going to need to make multi-extension file inspector just hardcode behavior inside of the CPP file. So I guess let's do that. Do that real quick. So we'll need a flag for this. In this case, I'll do static bool is multiple extensions selected. That's not grammatically correct, but is the style for names that I want to be indicated as bools. So is multiple file selections selected, and we'll start with false just to give it an initial value. And then we'll need to set this to be true. Here. So when we go to change a file selection, first thing we do is we unload the current inspector. We then parse out how many and which file extensions the selected paths have. And so at this point in the code, after we get through that iterator through the selected files, we know how many extensions there are, and we know which ones they are. And so when we go to construct a inspector for a selection that contains all matching extensions, then we will pass in the selected files set, which is a set of strings with all the paths, and the current file inspector, the newly constructed one, will take in and use those to load up the files. And it's at this point when the thing is constructed and initialized, when the texture asset inspector will read through all of the contents of all of the selected assets, and then parse out the data needed to populate the inspector fields. I have a little else blocks to put stuff in if I selected a file extension that we haven't handled yet. I don't know what I would use that for or if I will. We then have an else if for if we have more than one extension. So a mixed selection of extensions. And what I had been doing here was creating a multi-extension files inspector object inside of the current file inspector, and then calling a special initializer with a move constructor. So it takes the number of files with the extension and moves that data into its internal map so it knows which files are selected and which aren't. We're going to have to change that a bit. So I'm going to Control K, Control C. I'm also going to comment out the header for the multi-extension file inspector, so that way it's I'm not, if I'm accidentally using it in the code anywhere in here, that it'll give me red squiggles. And instead of constructing one, I'm just going to set that rule is multiple extensions selected equals true. And now for us to know which extensions those are, we're going to need to hang on to this map. What I was doing before is I was passing in the using this overload of the init call. I was doing a move of that map from the stack frame of the onSelectionChanged call and moving it into a member variable of this inspector. But that's not an option now. So what we're going to need to do well, there's a couple of things we could do. We could just make this global and make this available all the time, and then just populate it every time the file selection is changed. That's probably the easiest way to do it. Let me take a look at the code real quick for the multiple extensions. So with the multiple extensions on inspector GUI call, we iterate through getting every extension and how many of each there are. That makes sense to me. Yeah, so what we'll do is we'll just take the declaration for number of files with extension. We will make it a static. And then in here where we were declaring it, we are now, instead of declaring it, we are just going to clear it. So that it's empty when we go to do the parsing of all of the extensions from all of the file names. And I think that's good. Just move my mic a little bit. Okay, and then this will be available for use inside of the onInspector GUI call. So just making sure I haven't overlooked anything here. No, it doesn't look like we've overlooked anything. So down here on the draw call, whenever we go to draw the inspector, we currently have a call for if current file inspector, which is our way of checking to see whether there's an inspector registered, and if there is, we want to call it. However, we need to handle the case that there's no file inspector registered, but there's no inspector current because we have a mixed selection. So instead of doing, I guess we would just do another if block, wouldn't we? We would do if is multiple selections selected. That's kind of a mouthful. then we would just do the GUI here, and I can copy and paste. And instead of having a member extension counts, we now have, what did we call it? There was some confusion with some of the naming. Num of files with extension. And I gave it this weirdly long name because extension counts sounds too similar to extensions count. So maybe I'll come back and rename that stuff later for clarity. But basically, yeah, we do for every extension and count inside of num of files with extension, we basically just print a list or print a line of text on the inspector. And I'll worry about beautifying this later. But I don't have to do a whole bunch of if-elses here because these are all mutually exclusive. I should do an assertion or modify the above assertion because these if blocks are supposed to be mutually exclusive. If we have a selected entity, then that means we aren't selecting files, and is multiple selections extended? If is multiple extensions selected should be false. And also we shouldn't have a registered file inspector because the action of selecting a entity should clear the selected files and then invoke on file selection changed. Let me make sure that Boolean flag is actually set correctly. Is multiple extensions selected? It's set to true down here, but it's not been set to false up above. So yeah, so actually I'll need to move the clear stuff to the top outside of this call. So that way, when you go to change your file selection, the inspector object is empty, the map of extensions to counts is empty, and the Boolean indicating that we've got multiple file selections also reset to false. Yeah, okay, and that's good. So then down here we've got these. I should do a quick assertion on is multiple extensions selected. So presently we've got a slow assertion up here, and I do a slow assertion because this is a draw call. It's a done every frame. It's a hot code path, in other words, and I don't want this inside of my dev builds. We're asserting that selected files or selected entities, selected entities.size is being non-zero, and having a current file inspector cannot occur simultaneously. Hey, what's up? What's up? What's up? It's going good. I'm on a roll. Working on the serialization part of the inspector now. Arguably the most important part of it. So this assertion here guarantees that we don't have a file and a selected entity at the same time. But not exactly, because it's possible for us to have multiple file selections at the same time now, and not have a current file inspector. So actually, this is going to be selected files dot size, because selected files is how we define the presence of mixed selections. So if these are both non-zero, then we've got a problem. Otherwise, we're good. All right, cool. So that means, yeah, so if we've got a file inspector, so this means we've got only one file type selected. Then we have this little header. I'm going to say to do make better header section. I will, though, I'm going to take that note out because I'm going to be having to audit the whole thing when I go to beautify the application to make sure that everything is like good from a UX perspective. There is some information I do need to display now, or I want to display now. Before we do the apply and revert buttons in the header, I want to do the file name if there's only one file, and the number of files if there's more than one. So we'll do IMGUI text file, and then we'll do %s to pass in the path. So that'll be I'll do this as a ternary operation. So we'll say multiple selected files dot size greater than 1. And then if it is greater than 1, then we'll list multiple files, and then if it's equal to 1, then we'll do the actual file path. I'm stopping by to say hello. I couldn't stay up late because of health reasons. That's okay. Yeah. Just glad to see you here. Is everything going all right with your health, as you mentioned it? Okay, so what we've got here is file %s, so this is the printf style string, and then if we have more than one file selected, we'll say multiple. Otherwise, we will say we will pass in the selected file path. Maybe I should reduce that to a file name. I don't know whether I care too much about that right now. I'll worry about that later on. But we'll have the file selected, we'll have the apply and revert buttons, the separator, and then we do the on inspector GUI. I think that's good for now. Yeah, let's press F7, see if I broke anything. Okay, we did mess something up. What was that? Allocating an object of abstract type. How is that? Editor.h. So the texture inspector. Okay, so we're trying to instantiate the texture inspector, but it doesn't have. Did we not? Oh, I need to implement those pure virtual functions. That's why I forgot. So this is the texture inspector header. I have init on inspector GUI and cleanup. Now we need to do void on apply, and then on revert, like that. And then inside of the CPP file, we will need to implement that as well. I'll do that here. And this is where we're going to do our serialization code in a minute. F7. That should be able to instantiate now. that compiled. If we go to run it, and select a file. Cool. It says file name, apply revert. The second apply and revert is from the inspector, the custom inspector code itself, but that's okay. So the multiple extensions selected seems to be working fine. However, if we have multiple files selected, yeah, that's fine. That's working okay. I dig it. So I'm going to put the apply and revert on the same line. We'll get rid of that extra apply and revert inside of the texture inspector. I'm going to quickly do a trace inside of the on save and, or sorry, on apply and on revert, just so that we can confirm that they're working. Oops. And this one will be on revert. Cool. And inside of its GUI code, we will get rid of the custom apply and revert buttons. And then inside of the inspector panel itself, we will do same line on these buttons. Like this. And I'll just put these in the same row. Actually, I wonder what it would look like if I did same line following the file name, because it could be like file name, yeah, and put the buttons. I don't know. Well, I'll worry about beautifying later, but nothing special. I'm not in a good mental state. My birthday's coming up. It always depresses me. Anyway, you have a good day and productive work. Doritos chip. I should go to sleep now. Maybe see you next week. All right, man. Take it easy. You know, do something you love. Hope things cheer up for you, especially with your birthday. Nobody should have a rough time on their birthday. But yeah, I'll be here. Take it easy. Okay. Anyway, so now we've got the file name and apply and revert. I want to right align these apply and revert buttons, and I don't really want to spend too much time on this question of beautification, but it probably will be simple enough for us to do apply and revert to the right hand side here. So let's do that, and that way it's not so jarring when the buttons fly around. Okay, so we'll do same line, and that'll put the cursor back up on this line. I'm going to need, you know, screw it. I'm not going to spend that much time on this. I'm going to get rid of the same line call on following the file name, and so what we'll have is just the file name on the first row, the apply and revert buttons on the second row, and it'll all work fine. Perfect. Now if I click apply and click revert, I should be seeing on apply invoked in texture inspector and on revert invoked in texture inspector. And that's all we need to get started. So let's do on revert, because we planned ahead for it and it'll be the simplest to do. I'll get rid of these trace calls. On revert, because of the way that we parsed it, we parsed all of the files and stored 2 copies of them. There's a working copy, which is the data store that we pass into dir.imgui, and dir.imgui edits that when we make changes with the widgets. And then there's the revert copy, which is index 1 and all of those variables. So really, when we do on revert, all we really need to do is we just need to do a flip from the front to the back. So let's do this. I'm gonna find the variables in question. That would be the type field, paths field, min mag, map mode, slices, and the mixed flags. Oh, projections, I almost forgot them. The mixed flags for all of these values as well, because also because whether or not the field should be mixed is also a state that needs to be reverted. I will copy all those, and then on revert I will paste them. So now we've got all the names of all the things. We gotta reset, and I will do a multi-cursor edit, and we will say copy, and we will assign the working copy the value of the backup copy. Alt-Shift-F to make it all nice and aligned. And that actually really should be all of it. I will split up the mixed flags from the values themselves. Make it a little bit, I don't know, a little bit less of an eyesore. So you can kind of, it's easier on the eyes to look at blocks of text that are smaller sizes like this. And that should be it. Display values, backup revert values. Let's try it. I'll press F5. It'll rebuild and then run. I'll select a texture asset. So this is the texture 1 asset. I can change this to linear. I can replace the path with poo. Change the thing up here, then click revert, and now all the values are back to their defaults. Easy. The same should hold if we do multi-edits as well. Let's try that out. Click revert, and the mixed fields that we changed go back to being mixed. Cool, so that was the easy part. Now we have to do the onApply function. And it's not going to be super difficult, but it does involve using the serialization part of the Rapid YAML library, which this would be my first time even looking at it. I'm assuming that it's pretty intuitive because I saw the before I even downloaded it, I took a look at the code and I noticed that it looked pretty simple, but I haven't really tried to do it myself yet. So this will be kind of a learning experience, and it's probably going to be the worst part of this, to be honest. So let's close out of the header. Done with it. And in the inspector here, we do have access to the Rapid YAML library, don't we? Where's the Rapid YAML? Oh, that's interesting. Did we not have a... Oh, I got it collapsed. Hang on. YAML buffer. Okay, yeah, so actually what we're doing here is we're parsing the texture metadata with a helper function that's not inside of here. So we don't actually have the Rapid YAML data yet. So let me think about this. Because I could either do another helper function inside of textures.cpp and make it available for use in other parts of my code, or I could just do this all inside of the texture inspector. I think I'm probably going to do it all inside of texture inspector, because the question is whether it's useful outside of the context of texture inspector, and I can't say that. I can't say I can imagine a situation where another system would want to serialize a texture into a YAML file. Oh wait, no, that's not quite true. So I have to think about making things automatable inside of the game engine. That's one of the hugest perks of it's one of the hugest perks of being a software programmer, is that you can take your tedious work and make it less tedious. And the easier that is to do, the more you can do with it. That was weird. My keyboard just disconnected and reconnected for no reason that I could think of. Did I lose my internet connection? It doesn't look like it. All right, I don't know what that was about, but my keyboard is still working, it kind of looks like. Yeah, so it might be possible then that I'm doing a game and I am managing a huge number of texture assets, and I have like an artist that like is following like a file naming convention on their PNG files, and then I want to use that naming convention to deduce and automatically implement all of the details of the texture asset that it generates. In order to do something like that, you would have to either write the YAML yourself, or you could use a helper function. So it might be valuable for me to say, take this texture asset and serialize it to YAML, please. And then make that available as part of the editor API, so that way you can make a tool that will automatically do this inside of the enterprise editor. That sounds like a good idea, but I'm gonna hold off on that right now because I'm not sure exactly where that would live. It could be like in the public header. It could be something that like in the public header you that actually makes a lot of sense to put it in the public header. Right now, parse texture metadata. This is the API for it. We pass in a YAML buffer by reference, and then we pass in addresses of all the variables that we want to receive the outputs. And then you can just use this to say, here's my texture asset, and here's all the data I want out of it. I could do the opposite of that and make it public, and make both of these public. And then if you're writing a tool that uses the metadata of a texture asset, then you could just get it. That seems really smart, actually. That's what I'm going to do. I'll just do it right now. So textures.h. As a reminder, we do have two textures.h's because we have an internal set of headers and an external set of headers. Or a protected set of headers and a public set of headers. So textures.h inside of EP internal looks like this. Doesn't really have a lot in it, but it has stuff that needs to be visible to the editor and not to the gamer or to the game developer. Parse texture metadata I had fall into that category. It doesn't anymore. I'm making the decision to move parse texture metadata and serialize texture metadata. Those would be public. Because you never know, it might be useful. So inside of, I'm cutting that declaration out of here, and then inside of the textures.h, I will do, I guess I'll do this above load texture. We'll do parse texture metadata. And because I'm making this visible to the game layer, I'm now going to use the export macro EP API to make it visible across DLL boundaries. Okay, and then I'll need a similar function for serializing, which I will do here. And the plan is that the serialize function will be used inside of the inspector when we click save. And then any custom solutions that involve automating texture assets can use this as well. All right, so the API is probably going to be fairly similar. However, instead of having a mutable string reference, that's the YAML buffer, we're going to do a const string reference, which is the out path. And we'll use this to address a virtual path that will be receiving the texture file or texture asset. All right, and now instead of doing, sorry, loud motorist outside my window. Instead of doing these as out variables. These are the kinds of data that we need to serialize. So what we'll do is we'll take them. I'll take all the outs out of their name. Bam. And then I need to take the asterisks out of their name too. Good. And now I should probably make these by reference as well. So we'll make these immutable. So we'll do const by reference. And well, this one needs to go over a little bit further. And I need to, it helps if you spell const correctly. Like that. Okay, and then we got a function call that we can use. Before I forget, I'm going to quickly do descriptions. I may want to rethink, though, having all these parameters now that this is a public-facing API. Previously, I was okay with it because it's like, it's a very, I was treating it as a very niche tool that you just use it when you are, internally inside of the engine, and the game developer will never even see it. However, now that the game developer might use it, it would make sense for all this stuff to be in a structure of some kind. So let's do that. We'll do struct. This will be texture asset data. And it will contain all of these things. Just copy them directly into here. Get rid of all the, get rid of all the ampersands. Add semicolons. And now we've got a structure in which we can pass all this data at once. Do we have, did I declare vectors and string views? I have not. Let me do that up here. Good. And then we can simply pass in one of these into the into this section. Let me take a look at that. Before I move on, I'm just going to quickly confirm that this compiles. I don't think I screwed anything up, but I'd rather know while it's still easy to track down what's wrong. Okay, I did break something. What did I break? Unknown name texture type. Okay, yeah. So the we need to include the. Hang on, this is the public header, and there's texture handle right there. Oh, I accidentally got rid of the, oh, hang on. Texture type's not declared in this file. It's declared in, here. It's declared inside of the internal header for some reason. I guess I just didn't need to have it in the public header before, so I'll move it. That'll be here. Cool. Then we got texture type, cube map projection as well. And then we got the structure that contains all of that. Let me do F7. That should be working fine. All right. So a lot of these are simple enough. Texture type, texture filter, bitmap mode. Everything in here is either an enum or an integral type. The one exception is the paths vector, which is a vector of string views. We could do a like a move constructor or something like that. So what I'm thinking about is that the string view being passed in, if we're going to do a serialize call. Before I was just passing in pointers and references, and that made sense. So that way the memory for this remains outside of the function. It remains in the previous stack frame before the function gets called. But now if we're doing a texture asset data like this, it would have to be a pointer as well inside of here, pointing towards that, where the rest of it can be passed in by value. So I could do the paths vector in here as a pointer, and then you just pass in the address into the structure when you go to do this. I guess that makes some sense because we're passing in string views, which is going to be a view into the YAML buffer. Additionally, we're going to be using this as a return type. Let me quickly review the places I use this function. So in textures.cpp, there's the implementation. Inside of the load texture call, we use it. We pass in the address stack variables for that specific purpose. And that can be replaced by a return by value of the structure type. And then we use it a couple of times inside of the initialization of the texture inspector, where we use the addresses of the private member variables, except for here where we use stack. So this could be replaced with a structure. If this returned by value a structure, then we can directly assign that to these members. We would need a way for us to confirm that whether the parsing was successful. Okay, so I think I got it. What we'll do then is we will, inside of this call, instead of having outs, so we'll still return bool, so it's true if it's successful, false if not. We'll take in the YAML by immutable reference because that's how that works. And then we will take and return. We'll do an out of texture asset data. Pointer, and this will be data out. I guess that's the simplest way to put it. So you put in, you do a allocation of one of these, you get the address of it here, and then it populates. I was concerned about paths specifically being parsed out, because I don't want to be doing more constructions of a bunch of strings. But I guess they're all stack variables to begin with, so that's actually no problem. So what we'll do is inside of the structure up here, this will just be a regular vector of string views. Yeah. However, I'll need to make it absolutely clear inside of the API documentation that the paths will point to the strings inside of the YAML buffer that you pass in. But yeah, I think that's a good idea. I think this works out. Let me make that work real quick. And I'll document it. So this will be, well, this should have a different name to begin with. Parse texture metadata was kind of a little bit of a hacky name. Let me fix the implementation so that way we're using it correctly now that I've changed the signature. And then we will give it a better name, and then we will do the serialize portion, which is the thing we actually care about today. So this will be texture asset data, and this will be type and filter. What am I on? I'm on load texture. Yeah, I guess it would be texture data. We've already got the YAML source here, so we'll do if parse texture metadata, but instead of passing in the addresses of all of those stack variables, I just get rid of all those, replace it with a single stack variable of texture asset data, which is actually going to be texture data, and we're getting the address of it. Cool. So if texture metadata returns successfully, then we will do load texture implementation. And we were getting the type texture paths and everything else from texture data dot. Except for texture paths. Why though? I don't really remember. Let's rewind and double check what I deleted. Texture paths is a vector of string views. And texture paths from texture data. Oh, it's not called texture paths. It's called, what's it called? It's just called paths. Okay. Cool. And I could probably replace the implementation with the texture asset data as well, because it's almost all the same. Types, paths, slice rows, and yeah. But for now, I'm gonna just skip it and make everything else work. And then we have to do, when we do member access for these things, it'll be texture data dot whatever. Texture properties could also use this structure, but for now I'll just skip that as well. Okay, I think that was all the red squiggles taken care of. So that's that one. And we need to fix these as well. So instead of having all these stack variables, we'll just have the one texture asset data. And this is going to be the compare data. Like that. And then we'll do, instead of type compare and all that stuff, it'll be compare data.type, compare data.paths, min filter, mag filter. Wait, hang on a minute. I could also use this structure inside of the inspector. So if I go to it and we look at its private member variables, With one exception, we can replace all of this with 2 copies of the structure. Paths field is now is handled as a vector of strings in here instead of a vector of string views. Yeah, so here's what I'll do. I will comment all of these out, and we will have a member of texture asset data, and this will be field data, and it will be an array of 2, and inside of it, the field data dot paths is unused. The string views inside of here will be ignored. We will just use paths field whenever that's necessary. The is mixed flags, it doesn't make sense for me to dedicate a struct to passing those in. They're just a bunch of booleans. So what we'll do is we'll leave those as they are. But yeah, if we take a look at the texture inspector code, then we can make some changes. Or to be more correct, we'll have to make quite a few changes. So we're parsing the texture metadata into compare data. I'm gonna put this lower code on the back burner and redo the implementation of, or redo the parsing code during the init call, because this is where we actually populate the member structure. So all of these field variables, they used to be member. Yeah, these used to be the member functions. So what we'll do instead, I'll get rid of this stack variable. I will do the address of field data. So now the member structure, actually it should be field data at 0, right? Is that what we're doing? Yes, we were doing at 0. These were, we didn't have the ampersands on these because they are array types. I'm gonna do this. I know that it's unnecessary. I can just do field data without specifying. However, I want to make it clear that I'm only setting the first element. So I'm gonna do field data 0 in here to say this is the first element. We're getting the address of the first element, and we're not. Yeah, I don't know. I think this subtextually tells you what's going to happen in here. It's not populating both elements. All right, and then with the field data populated, we need to do a copy into the vector here. So we're going through every paths views, which used to be the vector of string views that was stack allocated up here. We are now going to go through field data at 0 dot paths, which will give us the same data out. We then go through paths field, which is the vector of strings, and then place back the strings that were strings constructed from these string views. So we're copying the data from the string views into the actual vector of strings. So that way it'll persist beyond the YAML buffer. All right, and then down here we were doing copies of the field values in the first element of the structure into the back element. So paths field is still separate. However, we are now going to use field data, the structure, to handle everything else. So field data at 1 equals field data at 2. I'll probably get better names. I'll probably rename these a little bit and give them better names later. Sorry, not at 1, not at 2, at 0. From the front buffer to the back. Cool. And then there's one last thing I got to do in here that it's kind of just a little bit of protection for myself. I want to go into paths. Path field data dot paths, and I'm going to say, arrow.paths, because that's the 0th element. Let me do this just to make it explicit. These are semantically the same, but this implies that I'm accessing the 0th element rather than dereferencing a regular pointer. And we will do paths.clear. And the reason why I'm doing this is because the string views, after we've left this function, after we've left the scope, the YAML buffer will be gone, and the paths will not point to anything. So they'll be invalid. So I will dispose of it, and I'll make a little note here. String views invalidated after init returns. We use paths field instead going forward. Or instead after this. And I'm going to put these comments right here. All right, cool. String views are invalidated after init returns. We use paths field after this. And then we do the copy from the front buffer to the back buffer. All right, that's looking good. Now we have to do the type corrections down here. We have the compare data. That's going to be loaded all at once using this second parse texture metadata call. And then if we've loaded successfully, well, that's interesting. So if we've loaded the first file successfully, then we loop through files 2 through n, and if there's an error loading, I guess we still continue parsing the other files, and I don't know why we do that. We should probably just break out of this, shouldn't we? Yeah, so if error is true, then we'll break. This will break us out of the for loop, so we're not going to continue parsing through the rest of the files, because why would we? We're just going to display an error message. Okay, and then assuming that we haven't broken, we do the isMixed checks. So type isMixed equals compare_data.type not equal to, yeah. So we're going to still have to do all of these mixed checks separately. So we're not just going to be able to compare the structures from the first file and the second directly, because we have multiple fields representing each element of that data. So they have to be compared on their own. So compare data.type, .paths, and all that stuff. That's looking good. We just need to change the member variables from type field to being something else. So this will be field data dot type. Field data at 0 dot type. And we could probably do that for the rest of this too. I'll hold off on strings for a minute because I'm gonna have to think about that. And then for these, each one of these I will paste the structure name dot, and then we will get rid of the field bit. Yeah, okay. And then what do we got here? Map mode underscore compare. Oh, I started converting these, and then stopped in the middle. So this will be, each one of these will be members of the compare data variable. And then I can get rid of the underscore compare. Alt-Shift-F to make things a little bit nicer. I'm not really sure that this is nicer, so I'm gonna break this up into, break the lines up a little bit. Okay, and that might be a little bit easier to read. I'll do the same thing for these. Cool, so that's everything but the strings sorted. So, I wonder if there's a simpler way to write these. If the field is mixed, okay, if it's not mixed, then we check to see whether it is mixed. We could probably do is mixed equals, and then do a ternary operation. Is there a compound ternary operator? Oops. Because that would be really elegant if there was. So there's the conditional operator, the ternary operator. Comma, function call. Increment, decrement. I'm looking for the compound assignment. Okay, there's not. What I was thinking was that I could be able to do something like min filter is mixed at 0, and then do question mark equals, and then if this is already true, then we will assign one value, otherwise we will ignore it, or assign a different value, but that's not quite the case. So yeah, that's fine. Yeah. So let's take a look at the strings now. For the paths is mixed, this is a little more complicated because we're comparing a vector of strings versus a vector of string views. So we actually have to do a loop through the compare data.paths. Paths compare.size. So we do a size comparison first. Paths compare.size is not correct anymore, I don't think. All right, this is the comparison one. So what we do is we do compare data dot paths. And we'll do the same thing down here. Right? Yeah. And so what we're checking is first that the sizes are the same, paths field compares the same. And then we check whether each string matches. So there's an equality operator on each element of the string view vector and the string vector, and we do a comparison directly. Okay, cool. So that should be fixed. Awesome, that looks pretty good actually. And then down in the inspector GUI, we got some things to fix. Type field is no longer a thing. It's going to be field data.type. Field data add 0.type. And we'll do the same thing for these. This is min filter. This is mag filter. This is mag filter. And then min map mode. Okay, good. And then on revert is the last thing we need to change. And this is actually going to be the easiest of them because now we are doing, now we've reduced all of these with the exception of paths to a single structure. That structure being field data. Okay, so field data is now being reverted. Paths field is being reverted, and then the rest of these bools, which are still individual member variables, are being reverted. Cool. Yeah, that was a fairly small refactor, but it took a little bit. The value is that now inside of the textures.h, we have now simplified the parse texture metadata function. So if a developer wants to do their own parsing in serialization, they can just use the structure type, and it'll be much easier on them than passing in a whole bunch of pointers. Awesome. Now we'll do the F7 and confirm that it compiles. Once we've done that, I'm going to pick a better name for it, and then we will do the serialize function, which will also use the structure. What we did modify the textures header, so that touches a lot of CPP files. Okay, we got some problems. What are those? Undefined symbol, parse texture metadata. Oh, did I forget to do the? Did I forget to change the implementation? I did, yeah, okay. So let's do that now. So this will be replacing all of these out variables with a single one. This will be the texture asset data pointer data out. and now we should get a whole bunch of red squiggles, and we'll fix that by replacing the affected types with data out dots something. So this is now data out dot type. Sorry, data out. Hang on a moment. Data out arrow type. Yeah. What's going on here? Pat's out. Right. Hey, Yolan. Not yet. But hopefully. Hopefully I'll get there. There we go. We are doing serialization stuff for the textures now. So now we've got all the components needed to do custom inspectors, and we're using that API for the texture inspector. We are going to be actually being able to save those changes now with the apply button. Yeah, let me think about this. So this paths out used to be a pointer to a vector, so it makes sense that we were doing in a place back. But now it's data out paths, and that's not an address, that's a reference. So we can do data out paths dot. Okay, and then this is type. This is projection. Slice columns. Slice rows. Which one was this? Slice count. And then this was row major. Okay, and 3 last. Min filter, mag filter, and so on. Okay, Alt-Shift-F. All that formatting should be just a little bit nicer. Okay, and there's one last red squiggle, and that was this guy. I missed one of the type outs. Oh, there's a few more. Okay. What's going on with IntelliSense? Okay. New filter. It's my configuration provider from. No, it's disabled, so I don't know. Don't know why IntelliSense has been giving me so much grief the last couple of days. More than usual, I mean. Okay, so that should be everything. The implementation should be fine. F7, build it all, and let's see what we got. Good, everything compiled. Let's make sure nothing broke. Those seems to be fine. If we open up a scene, the textures are loading still too. So yeah, looks like we're doing good. So this file doesn't open correctly because it's a bad one. I should probably just rename it. Let me do that. Okay. And then in the editor, I'll refresh the view. Okay. Then we've got, that's the bad texture. These are the good textures. Perfect. All right, now inside of textures.h, let's finish up what we were doing and we'll get the serialization working. Parse texture metadata probably would be better as load texture asset data. I think that makes more sense. Yeah, all of these. Replace, please. Cool. And then we are on the serialize call. So EP API, bool. I guess bool. So it'll return true if we were able to successfully save. Otherwise, it'll give us a false. And that allows, if you're doing an automation solution where you're generating or editing a bunch of textures at the same time, or texture assets at the same time, then you can handle the situation where it fails. So this will be load, and this will be, I don't know, save texture asset data, or save texture asset. I want to use the word serialize, but maybe that's unnecessary. Save texture asset. We'll do the path up here. String reference. Except for it's got to be a constant string reference because this is not a buffer. This is a path. And then we will accept by reference a texture asset data structure. Cool. Yeah, I think that's logical. I think we're in a good place here. I'll quickly do the documentation and then we'll move on. Oh, but in this case, we're passing in a YAML buffer, not passing in a path. So I should probably add a helper function for this. Well, okay, let me rename this back to parse. But it's parse texture asset data, which is still a better name than before. Confirm all of the changes. All right, and then this will be save texture asset, but we'll need to have a call that actually takes in a path to a file and then gets the buffer. Oof. Nope, I'm gonna skip that. I'll I'll just have whoever is using parse texture as a data, I'll have them responsible for buffering the, or maintaining the buffer for the YAML. And we'll move on with our lives. So now we're on save texture asset. I think that's probably a fair name. We have the data that goes into it. Data structure contains string views instead of just strings. Which might make this a little bit tricky, actually. Because if we look back at the inspector where we're actually going to do the serialization here on the onApply call, the data that we have for this is not a buffer of string views, but a buffer of strings. So eventually this is going to be like resolved with like a call to like save texture asset, right? And then we pass in whatever file path we have loaded, or we would like do this for every path inside of string selected files. I forget. There's a vector somewhere that we can get this data from, but we pass in a structure that doesn't have the strings in it. What we could do is we could take the field data structure, and then inside of its paths, we can make those reference the member variables in here. That would be one way to do it. But part of me is wondering whether it'd be better just to do strings and actually allocate the strings. This is something that's not going to be done every frame. This is something that's done only once in a while when you change the selection inside the content browser, or once in a while as in you're running a automation to generate or modify a bunch of texture assets. So it probably wouldn't really be a huge problem if we allocated a vector of strings every time. I'm kind of leaning towards that being our solution. I'm going to take a quick break though. I'll mull this over for the next 10-15 minutes or something. And when I come back, we will do one or the other. We will either switch to using string views, or we will make the string views work for the serialization API. See you shortly. All right. Good, unmuted and back. All right. So yeah, where did we leave off? We were getting the API for serialization, serialization of texture assets done. And while coming up with that, that'd be the other include. While coming up with that, we transitioned to packaging up the data for each texture asset inside of a texture asset data structure to make it easy to pass things in and out of these functions now that they're public facing and not protected. All right. But the remaining question was how to handle the paths, because each texture asset can have one of a number of paths. Up until this point, while this was an internal function, I was simply using string views into the YAML buffer, which is great if you care about performance. You don't want to be doing string copies all over the place. However, given the frequency and infrequency of loading these texture asset files, I think it's probably going to make more sense to change this to be a regular string. So that way this can survive any YAML string buffer, and we can have an API call that looks like this. Load texture asset data. That takes in a string that's just a path, and we don't have to do the YAML buffer ourselves. And then when it returns the texture asset data, what's up with IntelliSense today? It's so slow. The texture asset data structure, it will persist beyond this buffer. I think that makes a lot of sense. This does mean that inside of the parsing call, we will be having to make copies of all the strings from the YAML buffer. But I don't think that's a huge ask necessarily. If I wasn't making this API public, I would just continue with the string views because there'd be no need for a copy. But I think that usability for game developers comes first when it comes to code that executes in an editor. So we'll go to parse texture asset data. Now we have to do some changes, I think. Or do we? It's possible that the strings that we are passing out will use exactly the same API. I'm not sure. Pass.inplaceback pathnode.val.string and length. Oh, that's interesting. Actually, no, yeah, the code works exactly the same way because we're using InPlaceBack to push in the string views. But if we're using InPlaceBack on a vector of strings instead of string views, then the constructor actually looks the same. We pass in a pointer to the character buffer, and we pass in the length. Cool. So that's good enough for me. There is a problem down here, though. Texture data.paths. Yeah, so we'll make a few changes. Inside of the texture inspector itself, we no longer need this secondary paths field variable. We can just do everything inside of the field data. Great, that makes the code a lot more straightforward. And then inside of here, we will get rid of paths field when we go to change the front buffer to the back buffer on Revert. We could actually do way simpler code for the strings as well. So during the initialization code, where we take and load up all the selected files and do all their parsing and stuff, we now don't need to iterate through field data.paths anymore, I don't think. We can just do, make sure that I'm following this correctly. We don't need to clear field data.paths. And field paths doesn't exist. Yeah, we don't need to do any of this. We just simply assign field data 1 to be the values of field data 0. Because this will also take care of the strings, because it'll copy them instead of doing pointers to a YAML buffer. All right. That's looking good. And then down here, yeah, and our job is also a lot easier for doing the comparison between the path buffers, because now they're the same type, so we can just do it would be paths is mixed at 0 equals compare data dot paths is not equal to field data dot paths. Hey person, welcome in. How's your day going? Yeah, that's way simpler. Where lies the defining line twixt binary and grief? There is no line, it's all grief. Okay, yeah, this is looking... This has simplified a lot of things, actually. We're doing serialization of the text file, or the texture files, finally. So that way we can make edits to the texture files inside of the inspector, hit the apply button, and then it reflects inside of the YAML. But there's just a little bit of overhead to take care of before we get there. I've been fighting structuring. Yeah. I feel you for sure. What are you working on? Right, paths field doesn't exist anymore. That's right. Now it is data field data dot paths dot front. Yeah. My engine, yeah. They're complicated, man. It gets. I all the time I'm thinking that I'm doing better, and then I have to like I think I'm ready to move on, and then all of a sudden I'm like, well, actually it should be structured this way to make what I want to do possible. Eventually I'll get it right, but it keeps feeling like I'm failing up. That's I don't know, that's probably relatable. Fail faster, but fail upward. What's your engine being written in? I don't know if we've talked about it before. Got the amazing thing of having two separate executables for the editor and the runtime, drawing code from both the shared and private code bases. Nice. Yeah, that was tricky for me too. And it was a huge step. So congratulations. That's a huge deal. I understand how big of a step that is. Yeah, it's challenging for sure. I need to think for a moment about how I'm doing this. So previously this was a string view, I think. No, this was a string. Right, so we're passing in the address of a string. Right, now I'm back on track. So this is Yes, what, by the way? Yeah, like tell me about your engine. I don't know if we've really talked about it in depth before. Right, okay, so this would be field data paths dot front. Yeah, perfect. It's written in C using pure 132 and DirectX 12. Nice. Called the Skive engine due to the development history. Ah. Dude, pass a link in the Discord and I can take a look at it later. If it's open source. If it's all offline, then obviously don't. Don't have anything public yet. That's cool. Not everything has to be on GitHub. What does skive come from in the development history? I don't know what skive or skeeve is. Okay, I think that's all. Everything's set up in the texture inspector. Cool. And then we have to fix some of these problems inside of textures.cpp. Been working on it for 2 years, and functionality has been removed, if anything. Oh, really? So you started off with something that was really robust, and then you're building back up to that? Or do you mean something else? Low texture implementation needs to change. Okay, that makes sense. Right, because low texture implementation takes string views. All right. So where's the? It would be in the protected header. This guy. So this is going to take strings now. Cool. Started off with C with classes, C++ and SDL. Hopped from SDL rendering to OpenGL, then ditched SDL and C++ and moved to Win32. Yes, yeah. Now you've replaced all of the parts, like the ship of Theseus. Is it the same engine that you started off with? Now that you've replaced all the APIs, that's fun. Yeah, I don't know if you had come in yesterday, but we actually started to do some object-oriented things in the engine. I rarely do object-oriented stuff on stream, but yesterday I implemented a specialized templated container that I came up with called a poly union, which I think is a handy enough tool that I'm going to probably just like do a little video or a blog post about it and just make a GitHub gist. I've never done a gist before on GitHub, but yeah, for the most part, I'm still there with you with C++, C with classes. I've lost count how many times I've completely rewritten everything as well from it being too complex, so I reset it and redo it the same way as it did before. Yeah, sometimes it's you got to do that assessment and say, is this worth using as a framework? Because like even if you're if you're planning on changing a whole bunch of stuff, that doesn't mean you have to get rid of your old code. For example, there was a engine I was doing like a long time ago, like 6 years ago or something, that I used to, when I started up with this engine, I was copying and pasting code from. Said many times this is the last time I reset. But there's always one more, right? At least Skype is the end of this madness. Yeah. I'm at that point where I really need to get this one finished and actually say that I've got a finished product instead of continuing to start over. That's my main driver on this, and I'm farther along than I've ever gotten before. But yeah, it's I feel your pains. Yeah, so the implementation function now takes strings instead of string views. How far along did you get with your previous attempt? So actually this code, there's literally no red squiggles after what I've done, after I've changed. Because a lot of the APIs for string view match strings exactly. So they happen to all line up perfectly in this case. However, I can do a couple of things. Like I can use the regular std string version of virtual path. SFRT, stop stop fucking resetting this engine. Yep. Ironically got reset. But it was a disastrous amalgamation of 3 different human languages. Oh boy. Oh, I think I kind of remember you mentioning this before, with the with multiple languages, one of which was your own. Yep. So we will do this. Yeah, English, Norwegian, and Miskas. Okay. And is Skive a Miskas word? No, it's actually English. Miskas is an English word? Or is it... Or, sorry, Skive is... Oh, hang on. This is an English word, isn't it? I just don't use it very often. To avoid duty by good. That's an obscure word, isn't it? Well, I guess it's informal in British though. That's or in British. It's not a word that we use a lot in the States, at least not the places that I have lived. That's fun. Skive. Skive. Learn. I just learned to pronounce it. It just
Skive.
Why do I? What's this link do? I gotta see what this link does. Hang on. Practice. You can practice saying Skive with the Google AI. Hang on. Yes, Skive. Sounds like you said Skive. Good job. That's funny. I didn't know that there was a pronunciation trainer on Google. Google does everything. Does this still have my microphone? It does. Cool. All right. All right, back on track. Virtual path to native. What do we got? Equivalent native path. What's it complaining about? Path is undefined. Oh, path is undefined here. Path. This is not path. Okay. It's actually in Norwegian too, but it's for i.e. a slice of bread in Skive broad. Nice. You learn something new every day. Okay, I think that's that. Inside of the implementation, I'm just going to quickly read through and make sure that the change to using strings doesn't break anything that I'm not thinking of. Yeah, it seems good. Well, SE isn't completely free from discuss. What parts did you keep? Fedulink and the MDL shortening for the editor. Nice. Okay, so I think finally we're ready to move on. Let me take and comment those out real quick. Confirm that everything still builds, and then we will move on to the serialization part. Finally, 2 hours in. Tell me, how do you shorten editor and do something shorter? You don't. Yeah. Well, you could do ed. That's what Unreal does. Unreal ed. I had thought about for a while, like coming up with like a fun name for my engine's editor. Originally, back in the day, I had a little toy engine that I was making with a friend, and we were Star Trek fans, and so we picked Enterprise because of that. Um, and so we were thinking that we would like name all of the things inside the engine after like Star Trek stuff. Like it would be the LaForge editor or something like that. But I wound up sticking with the name because I needed to pick a name and I didn't really want to come up with anything else. But ultimately I decided to just call it the editor and not think too hard about giving it a fun name. I don't know if you follow the Cherno's game engine. He has a video series going on about it, and his engine is called Hazel, and the editor is called Hazelnut. That's a fun one. Visual Studio 17.4 preview adds support for C23 attributes. That's cool. And C23 attributes are the attributes that you can customize, right? Not sure. In C++, technically, there are attributes, but they're all fixed. The C++, I think they've been around since C++ 11, actually. But in C23, but it's a good sign for full C23 support. Yeah, nice. Yeah, attributes are so helpful. That's one of the best parts about working in Unity is the attributes that you can just like make a class and then put the attribute, say, make this an inspector, or put this inside the right-click menu, and then it just does it automatically. I would like a good embed for what I want. Yeah. Yeah, there's so much stuff that languages could do for you that most of them don't yet. I'll be honest, like I enjoy C and C++, but I really can't wait for a popular, useful replacement. Because I think that we're at the point where we probably should start over from scratch. I haven't tried Rust yet. I know that Rust is a popular alternative, and so is Odin. But I've said this a number of times. The one I'm really looking forward to is the Jai language from Jonathan Blow. Okay, so I think we're back up to speed. I'll quickly write this wrapper function because it should be really straightforward, and then we will finally be saving the changes that we make to the textures inside of the inspector. So low texture asset data. This is basically a wrapper for this. I could probably even do it in here, but I'm going to do it in the CPP file instead because it does involve creating a buffer. So textures.cpp here, and we'll go to parse texture asset data, this guy, and oops, right below it we will do the bool load texture asset data, and this should be really straightforward. We just do a YAML buffer. We will do file load text file, passing in the path that we received as a parameter, and then passing in the YAML buffer reference, and we will say if the load is successful, we will call parse texture asset data with the YAML buffer, and we will get the data out in the form of a texture asset data variable. However, data out is provided as a parameter, so we don't even need to allocate that here. We can just do data out, pass in its address, and then this will populate that directly. Cool. And what are you complaining about? Expression must have a bool type. Oh, right. This returns an error code. So if it equals file error code success, then we will move on. Else we will say Shit broke. Shit's on fire, yo. So this will be graphics load texture asset data. Give a helpful error message. We'll say error loading texture file, texture asset, and then pass in the path. But yeah, I've been trying to pick up all sorts of English. Not a 4,000 line PDF of the Oxford Dictionary. You got a 4,000 line PDF of the Oxford Dictionary and a 2,000 pages thesaurus. Oh geez, that sounds like a lot of work. Are you talking about, I mean, not to learn English, right? Because you speak English very well. You mean just like for looking for names for things? Oh, the most important part is that we return true. Like that. Return true if we loaded correctly, false otherwise. Though the parse... Oh, I just have to return the value of parse. Yeah, return this. Because this will itself return true or false if there's a problem. Right, perfect. Easy. And you know what? I could probably just use the load call instead of the parse call in the places that I've used the parse call. Huh. How I found Skive. The dictionary has a possible origin for some words, and I just searched for stuff coming from Old Norse. Oh, nice. Another little reference since I'm Norwegian. Yeah, nice. Nordic words are cool sounding. The Nordic languages. I don't really know anything about these other languages, but I know when they show up in like television and movies, I always love the way that they sound. I'll leave this as it is. I can technically now use that wrapper that I had and replace this loading code with just a call to load. Actually, that's really easy to do. I'm just going to go ahead and do that. So we'll have texture asset data. Provide that into parse. Get rid of this and this, and replace parse with load. And instead of passing in the YAML source, we'll pass in the path. And that's it. F7. Language and culture can create some good humor. Yep. Which no one else understands. Inside jokes are the best jokes. That's for true. That's for sure. Okay. So that's looking like it's going to work swimmingly. Quickly check the other use I have for parse texture metadata, which is in where? I think it's in the texture inspector, actually. Yeah, I can actually wrap this as well. Got a low-res image of a sign in Norwegian coming with an aggressive message against littering. Okay, so in this case, I actually don't want to do wrapping because in the case of a parse failure, what's going on here? I don't think Google Translate works either to dual dialects or due to dialects. Oh, really? It's not good for Norwegian. I know that there's historically been a problem with localization that's automated. A very dialected language. I think there's something wrong with this code. Having trouble putting my finger on it. So if this, oh, it's just structured weird. So in this context, we can simply replace this with this. But the path is selected files.begin dereferenced. Because selected files is a set instead of a vector, we have to do this awkward dereferencing of an iterator thing. We do all have one writing dialect, Bokmal, in common that everyone understands and is used everywhere. And public stuff also use Niorsk, which is against most everyone's will. It's more talking, which is heavily dialected. Interesting. Yeah, the from what I understand of Mandarin and Chinese, like Mandarin is similar. It's the version, the dialect that everybody uses, and there's others which are less common and fewer people are okay with using. Anyway, this code's a little simpler now. We're using the helper. What's with this? Qualifiers dropped in binding, reference of type, std string reference to const std string. Doesn't it? The operator should be giving me a. Oh, I didn't make this const. Yeah. Let me do that. Yeah, this should be const. Const. Good. Awesome. And then this should be matching qualifiers now. Perfect. I don't know how I keep getting distracted, but I do. Oh, what did I screw up here? Stop building, please. Come to New York. State News has a goal to have 25% of all content written in that. A terrible shame when you find an interesting article and you need to spend extra time reading it for no good reason apart from satisfying the 2% that prefer. Yeah. I have mixed feelings about language support because eventually, if like the human race is going to like unite and be like one human race, like we'll have to have the ability to communicate with each other, which means that everybody has to know the same language, or everybody has to speak at least one language in common. But then there's like a cultural association with languages that you don't want to forget them. Yeah, it's hard. Until we come up with the universal translators that they use in Star Trek, we're going to be fighting these difficulties with making sure everybody understands each other. Okay, so yeah, I've got to make a change here on the load text file. I don't need to do load text file anymore. I can do load texture assets data. With file path. Just learn English, Mandarin, and your local language, and now you can talk with almost everybody. Yeah. Yeah. In the U.S., the second most common language is Spanish, and I've had it as like a back burner item in my head that like if I have extra time someday, I'll actually spend time on learning Spanish. But I've never found that time. Interestingly. Meanwhile, first loop. What are you complaining about? Yeah, that's fine. One thing that I don't like about working in VS Code is that when I go to do a compilation and then there's an error, the squiggles don't resolve until I try to compile again. Passively writing down words for my miscast language and slowly expanding it and procrastinating or organizing the dictionary and making everything clearer, being the only one who understands it. Yeah. Okay. And this code just got a lot simpler looking too. Ugh. Okay, that's compiled, so we should be back to operational again. Cool. Inspectors loading things fine, and we open up a scene, and the textures look fine as well, even when the game runs. Cool. All right. Cool. Now we do the serialization. 2.5 hours into the stream. So we'll go to textures.h for the public-facing one. We will uncomment the declaration. I'll copy the signature. I will go to textures.cpp, and underneath the load texture asset data, we will do save texture asset data. No, I'll just call it save texture asset. All right, so it'll take the const reference to the data to serialize and give you the path. Now this is where it gets tricky, because I've never used YAML to serialize before, so we're gonna have to learn how that works. So let's go to the demo. Look for the emitting. Here we go. So here's the getting started example for emitting YAML. Looks like there's an emit YAML object that you can pass a tree in, and an outstream. There's also emit JSON. Okay. I'm not sure how much I like the idea of doing an outstream, but we'll work on that. What even is YAML? YAML is I forget the exact thing. It's YAML ain't a markup language. Is what it stands for. Yeah, YAML ain't markup language. It's JSON without braces, basically. And I have mixed feelings about YAML. For our purposes, for the purpose of serializing data, I think it's fantastic. But it's spec, like people use data files like JSON in the web world a lot, and YAML doesn't really work super great with it because it's got like these weird arbitrary rules for typing the data. It, like, if you use the capital letters NO, this is a very famous example. If you use the capital letters NO in a value, a YAML parser following the YAML specification will interpret that to be a Boolean false, like as in yes, no. Whereas maybe you just want capital NO for your string, like isn't that Norway's country code is NO? Or yeah, it's like so it's not great on its own, but used purely as a way to store data, where my code determines what type to cast to. NB's, yeah, exactly, yeah. So it's like it's complicated, and the type system, and there's a subset of YAML. It's called strict YAML, which basically takes the YAML specification and then strips out things that make it so messy. The most important part of which is that you are not that the spec does not prescribe a type. The YAML parsers that follow strict YAML will only associate the keys with strings, and then it's up to you to decide whether to cast it to a different type. And that's the best way to do it. It doesn't actually say so in here, I don't think, but I'm pretty sure Rapid YAML's library adheres to strict YAML. There's no part of this that involves doing casting for me. Human readable data files, yeah, and it's great because like if I look at the scene file, this is a basic scene file, and it's you use the YAML parser in here. It's not so hard to understand what you're looking at. It also for me the problem with JSON is like having commas at the end of every line. Because you'll run into that situation where you want to add an additional line, but in order to do that, you have to add a comma to the previous line. And so in your git commit, if somebody does a diff on your change to the JSON file, then they'll see that you edited a line that had nothing to do with what you wanted to change. And if you had too many commas, then it's badly formed. Yeah, this is far better, in my opinion. Good for development, sure, but raw binary offers smaller file sizes and faster read-write speeds. Of course, yes. Right now, the engine does not support binary blobs or binary files, but this is entirely just for development. You're right about that. So this is something that you would commit to your source control when you're making a game, and then you can, if you make a change to the file and you see that there's a conflict, you can just take a look at it and be like, oh, I added entity this at this position, and then you can merge it really easily. Plus security through obfuscation. I would say security through obfuscation is false. Like it doesn't exist. There's always going to be somebody who will unobfuscate it, and like there's very few things that can be considered safe from a security standpoint. For the stuff that I'm making, I don't actually really care too much about whether I'm shipping plain text stuff. There's actually like top selling indie games that they just literally will ship plain text files. Like if you've ever looked at the code or at the installation of Celeste, I don't know if you ever played the game Celeste. It's a great game. All of its stuff, like everything, like from the sprites to the lines of dialogue in the game, to the levels, it's all plain text, and people go in and they modify the text files and change what the game does. Yeah, really easily moddable. But yeah, for the kinds of games that I'm working on, I'm not really worried about security. If there's anything that I actually cared about security-wise, like on a networked game, I would be implementing security on a server so that it's like not easy to access. Yeah, truly, the only true security you can get nowadays with computers is air-gapped computers, which defeats the point if you're trying to make a networked game or something. Anyway, so for now I'm just doing YAML. I'm just doing the text assets for everything. So when you go to play the game, it will. I'll just demonstrate real quick. When you go to play the game, it actually does read the text-based files and uses them. But eventually, I'll be adding an API which will be supplanting those. And I've got some places in the engine where I've actually got the API, like a placeholder for the API, but I haven't actually implemented it yet. My end, I find it easier to fill out a struct and code and then compile instead of adding an interpreter. Yeah, that's sure. But if you're using, and that's the perk of something like YAML or using like a YAML library, is that you're not having to do a huge amount of work to reinterpret a file. If you're using a helpful library, you can usually get that data really quick. Because like in the case of the YAML, it took me a while to get used to it, but literally just like, does it have this key? Yes, then give me the value, and then that's it. But yeah, like if you go to like play the game, like if I change this to the actual all-in-one test game, it will read, even in release mode, it'll read the text scene and read the text assets and interpret those, and it's still really fast because there's not really much going on. So probably for the first couple of games I'll be okay with not packaging up everything, but eventually what we'll be doing is we'll be adding an encoder type, so a class that similar to the class that we've got going for the like this, similar to the class that we've got going for the custom inspectors. It'll be a job system module, like something that you would that would be loaded up into a thread, and then on a multi-thread basis it would be running the correct encoder on each one of the asset files that you've registered. Could use my config system for that as well. does this key exist, or give me the value, or give me the default value. Yeah. I actually went and wrote a whole INI parser for this engine, specifically for specifically because I had input in mind. This is the form of an input configuration file that you would see on a computer that's on like a shipping installation. And there's a whole API that allows you to do all of this and easily read the values in and out. And it adds extensions as well. So I have these dictionary values that go with keys. So I can say assign all of these data points to this access mapping. But yeah, you do the API well, and it'll become really simple to work with text files. But yeah, let me read through this code real quick. So that's reading init. Implement. Okay, so this is the quote-unquote the demo for emitting. I searched from the top and searched from the bottom, and this is the only example that came up inside of the quick start. So we emit to a file. We make a emit YAML object. They're passing in the tree from earlier. Maybe they just need to make a. Maybe this doesn't have to have anything in it. Maybe it just has to be a tree, and then we populate it. In this case, they're doing std out. Let's see what the signature looks like inside of the YAML library. So we've got the our YAML loaded in here. So we have access to that namespace. If we do our YML : emitter. No, it's emit. Huh. There is a class in here called emitter, but I think I'm not supposed to use it. So there's emit YAML, and then what does it take? It takes well, there's actually 6 overloads, so let's read through them. We've got a const reference to a tree, and then we've got a file pointer, a file handle. File in all caps. That could be the Windows file type, but I doubt it. I'm thinking that maybe it's something that is part of the C4 library. There's also ID and file F. If the tree is a const reference, though, okay, you can do a node as well. So you can either do the whole tree or you can do just a node. But if they're const references, then I wonder why you pass them, because what you're gonna... Oh, I get it. So you probably pass in the reference, and then you populate the tree or the node, and then when you're ready to go, it'll write to the file. So they have a string stream. Oh, each of these is... Okay, I'm following. So this is literally just emitting the contents of tree. It's not having anything to do with constructing the tree. Okay, I think I'm following. So you can emit to a file, you can emit to a string stream, to a buffer, so std string result can take the output. Can emit to any given buffer. Okay, so if you pass in a buffer as the second parameter of the constructor, that'll work too. Okay, I think I'm following. So actually, what I need to know is how to populate the tree. So I need the tree. Let me do a YAML tree. I could construct it from something, but I don't really see the point. And with the tree, we need to add stuff. So modifying existing nodes, scrolling up a little bit. So this is all hierarchy and reading stuff. And then here we've got modifying existing nodes. we have the shift operator, we have the assignment operator. As implied by its name, constant node reference is a reference to a const node. It can be used to read, but not write. If modification is desired, then a node ref must be used instead. Okay, so basically you get the tree, get a node ref, and then you can change it. Operator equals assigns an existing string to the receiving node. This pointer will be in effect until the tree goes out of scope, so beware to only assign from strings outliving the tree. Now the tree is pointing at the memory of the strings above. That is okay because... So they got a node ref to the tree, so the root ref gives you the base node. And then they just provide keys, it looks like. That's pretty straightforward, actually. I like that. Now the tree is pointing at the memory of the strings above. Okay, that's okay because they are static and they will outlive the tree. Okay. And then when you go to access the values in the node, okay, that's really easy. I like that. My first thought though was that that you'd have to actually create the child node before you could do something like this. Bar, and then just assigning an index to it. Oh, but we're modifying existing nodes. The foo and the bar keys, if I'm remembering right, they're assigned at the top with the, yeah, up here, where we pass in this string. Foo and then bar is already a sequence of 2 numbers. Okay. Okay. So adding new nodes, this is the thing. We get the root node, and we can add a key directly by passing in string that doesn't exist, it seems like. So we do that, and we go to assign to it, then it gives us a key. That's good. That's easy. And then you can append, serializes, and assigns the serialization. So you can insert a key and a value. So each line here added a node. Okay, so that actually seems really straightforward. So when we go to save, then we got a tree. I can do the square operator to add nodes. Let's open up a text file to make sure I've got it in the format correctly. The first key that I care about is the type node. And what, that just adds it? Oh, I need to get a root reference actually. So that would be YAML or RYAML root node ref is what I need. Node ref root equals tree dot root ref. Okay, I'm following so far. And then we use root, which is mutable. And then when we do the key, it will add it. And here we assign the value directly. Okay, so how do I add a map node? That's down here. So we add a new map. We have to or equals the type. So we say that's the RYAML map, and then we can append children. As a sequence. So this operator, the bitwise OR compound, is apparently used to prescribe the type. So we use key new map serialized as a sequence. So we prescribe what the value type will be, even if we're not assigning the value type. That's an interesting way to do it, but I guess it makes sense. It's not a whole lot of extra text to type. And I can kind of move on from there. What I'll do for my first tests of serialization is I will output these to the console. So I'll format what the output I think should be, and then when I click apply, it'll print to the console what the serialized YAML would look like, and then I can confirm that that looks correct without having to go and undo the changes. Okay, so we need type. Type's not a map, actually. Type is just a regular scalar. So this needs to be assigned something. And just to confirm that everything is working, I'm going to start by assigning junk values for the sake of testing. So we start with type, then we have paths. Paths is a sequence, so we'll say or equals REML sequence, and then min filter, mag filter, bitmap mode, and wrap mode. I'll just copy and paste those names. Not wrap mode though, because we don't use that yet. Slices, projection. No, we're not using those either. Let's just do these. Oops. 1, 2, 3. Oh, I selected 4. Okay, and then these will be okay. And then we'll need to assign a few strings to the paths. So what I'll do is I'll get a reference to the path node. So it'll be REML node ref, and this will be the paths node. It will be equal to root paths like that. Okay. All right, and then just like that, I can do paths node at 0, assign it a string 1, and then do that a few more times for string 2 and 3. And then I guess that's it. I guess that's the tree constructed. And then what I just do, REML emit YAML, and then I tell it where to put it. Okay. So what I'll do is I'll do an std string. That'll be the buffer. And then inside of this container, we assign it emitters YAML templated to string. Emit RS is what it says. I'm not sure what the RS stands for, but we'll do that. Emitters YAML std string, and then pass in the tree. Okay. Right? Is that good? Okay. So at this point, we should have constructed a simple YAML file. We've got the output emitted into this string, and then I'll do EP trace. I'll do info actually, and we'll say save texture asset, and then do the output. All right, let's give it a shot. So I just need to select a texture, click apply, and then look at the debug console, see what I got. Nothing? I got nothing? How did I get nothing? Oh, I'm not triggering save texture asset yet. Let me let me do that. This actually needs to be called from the inspector. So this is the texture inspector code. On apply, we will do EP graphics texture save texture asset, and we'll pass in. Oh, we'll have to pass in a path, won't we? Well, I guess we're not actually putting it out to any file yet, so I'm just gonna pass in nothing, and then pass in texture asset data, which doesn't actually have to be anything yet because I'm just testing out the printing. So I'll just do texture assets data example, and then pass in it. Cool. So this will trigger the test code when I click apply. Cool. And textures, select a texture and click apply. And we have a assertion failure, so I screwed something up. Let's look at the call stack. Okay, so the assertion failure occurred in a node method call. So it looks like accessing root type gave me the trouble. At least that's my read of it. So I'm going to stop debugging. I'm going to set a breakpoint to the line before, and we'll step through it. Okay, so we're about to access the root child type. So let's double check that adding business. Adding a key val node to a map. Yeah, I don't really get it. It kind of looks like the first mention of this new key val is here. So is the problem that the root node hasn't been made into a map yet? Maybe that's the problem. Maybe I have to create a map first. So let's try that. So root, we'll do that compound or business, and say YAML map. And then from there, I'll try inserting keys. Let's see how that goes. Okay, well, it didn't crash, but the output is wrong. Oh, I have to assign it. God damn it. All right. all right. This is learning pain, so this is good stuff. The best suffering is the suffering that you learn from. Here we go. Apply and debug console. Okay, look at that. Paths, string 1, string 2, string 3, min filter, or mag filter, map mode. In fact, the only... Oh, here's the type. Okay. That's excellent. Look at that. So this is actually really simple to use, now that I know how to do it. I make a tree, I make the root node a map, and then I can just insert keys and values. I can directly make the value a string, or I can make the value a sequence or another map. And then I can take that node and insert things into it, and I can insert into the paths using the index, though I probably will want to do insertion of paths as a loop, so maybe there's an alternative for that. Insert child, maybe? Let me read how this is done. Sequence. Adding a value node to a sequence. Adding a sequence node. Dot append child. So these are two different ways of adding a sequence node. This is the one I prefer. The number of children gives you the number of elements inside. And then, where are we gonna do? Where's the insertion of a child without knowing the index? The library seems to be really easy to use, but the using the tests file as the instructions is not really doing it for me. My best guess is insert child would be that we insert what we're going to insert. So you can insert a node ref or a node init, which I'm not sure what that means. I guess we'll have to do... Well, not insert child, actually. Dot append child. Yeah, that makes more sense. The trouble being that I need to set its value. So we can pass in a node init. So I'm guessing that that's what this business is, RYAML key or whatever. So I'll do RYAML scalar. No. I'm just going to try this, string 4. Yeah, that appears to not cast correctly. So, oof. So I can access the first and last child, and what that'll give me. the ability to write out a string to it. That doesn't appear to be causing problems. So as an experiment, I will try this code out. I suspect that last child will overwrite string 3. It'll give me the access to string 3 and then overwrite it. It did. So if I can gain access to the child, I can assign it. Okay, I think I've got it. Append child will give us the node reference. Okay, and then from the node reference that we get back, we can directly assign. So I guess the way that I would add children is I would say append child, and then I just assign directly. And if that's all it takes, then I'm mighty pleased with this API. And I think I would be totally down with using it for everything. Yeah, look at that. String 1, 2, 3, 4. It was good. It was good stuff. So I guess that means that we're ready to actually do this API correctly. That we're actually able to do the texture save and save changes to the files. I'm going to open up, before I forget, I'm going to open up all the texture assets that we're going to test modifying for. Because when I make changes to the files in the editor, I want to be able to undo them from Visual Studio Code. Visual Studio Code is great because if you have a file open and then another program makes changes to it, it not only detects that those changes were made, but it adds it to your undo history, so you can literally just undo what the other program did. It's great, particularly for projects like this. So I'll leave these open, and then as I make changes, I can watch this window to see what it does. Perfect. All right, so in the texture inspector on apply then, we need the ability to call save texture asset on every file that's selected. So as a reminder, the inspector only exists if you have selected textures. So literally for us, it's as simple as looping through all of the selected files, and then from there serializing to that path. So and right now I'm realizing that I don't actually have access to the selected files anymore. So when we go to construct the inspector, we get the list of files to load. We also need access to the list of files to serialize. So what we'll want then I could just keep a copy of this inside of the class. That would be one way to do it. I could also make a private member. But why make it private? This is not a case where I need to worry about protection. So if I make a member of the file inspector class, so that's the interface for all the custom inspectors that we will write, I could make a member of this class that is the set of files that's loaded into it. I could also add on the on apply. We could at that time pass in the selected files. That would be another way to do it. But it's going to be the same selected files from init to destroy, so Yeah, for simplicity's sake, I'm just gonna pass in the selected files again to the onApply call, and then I'll worry about making it nicer later. So texture inspector.h, we will now add this to the signature, and then back in. Are you gonna stop complaining IntelliSense? Then back in the CPP file, we will have access to them. Cool. Awesome. So here we go. We will have a for loop for every const std string by reference file in selected files. We will call save texture asset, and then pass in the file path here. And these are all virtual paths because they're being provided by the content browser. And then we need to pass out the data that we need, and that's going to be the member field data. So whatever we've got set in the field data. Oh, but it's actually a little more tricky than that, isn't it? Because we don't know. Oh man. So the problem that I'm running into right now is that if I was to just simply do this to say save over every selected file with what we have in the field data, the problem with that is that some of that is mixed. We don't know, like not all of the data that's in there is ready to be written out. For example, and I'll just pull this up in Unity because it's my perennial example. If I make a change to one aspect of these selected files, and then I hit apply, I don't want it to be changing the things I didn't change. I only want it to be changing the texture shape, right? The thing that I had changed. So we need to actually do something a little more complicated. We need to be able to tell the serialization function which things need to be written and which things don't. So one way to do that would be we could keep a separate structure for every single selected item in memory. I think that's a bit absurd. We could also, in the structure itself, track whether the field has been modified. I don't see why we would do that, really. We could also pass in. We could also, inside of the texture asset, pass in like a bunch of booleans to indicate which members of the data structure should be serialized. But that also seems kind of clunky as well. The best thing that I can think of right now that seems the most practical option would be for me to separate the save texture asset call from the code that we use in the inspector. So in the inspector, we would actually directly write the YAML out. And then this function, where was it? Here. This function, the save texture asset function, that's still very useful. But it would be answering a different job. It would be for this specifically for saving an edit in like a texture editor or something like that. Maybe, I think I have a slightly better idea. Maybe we should have an API for the sake of being able to edit specific elements. This is a tricky one. So the question is, how do we handle? Where do we handle the merging of data from the data that's inside of the file already and what's been modified in the editor? Or more specifically, what's been mixed in the editor. We don't need to track whether a change has been made. We can simply use the mixed flag to determine whether or not it's appropriate to write that data out. Because if it's mixed, then we shouldn't be. I'm going to take a quick break and think about this, about how I want to approach this problem. I'll be back in like 10 minutes, I think. Okay. All right. Had a little break. Excuse me. All right. Back, had a break, mulled over this problem a little bit, and I think I've kind of come up with the solution. So the problem that we were just dealing with was when we go to apply changes from the inspector, we don't want to actually be overriding the entirety of the contents of each file. We only want to overwrite the details that have changed. So ultimately that means that this API won't work, at least in this context. However, the follow-up question of where do we use this API, or should we have an additional API for doing changes to only a specific set of aspects of a texture asset file, I think it's still the same. I think it's that we should be using this when we are automating things. And the reason why, the scenarios that I imagine we would want, that a game developer would want to automate things on texture assets, tends to be iterative. So that is, you give it like a job, you say, here, do this task to these files, or do this task to all files. And then the task will go through, open up the file, do the thing to it, and then close it. If you're making a texture asset editor, which another thing that I want this engine to support, it's not super hard to imagine how that'll fit together, then you probably will not be working iteratively, but you'd have to like do your own serialization code anyway, to be able to work with the intricacies of your editor. So and doing a texture asset inspector or a texture asset editor is very unlikely anyway. So I think I'm fine with just doing this API, the save texture asset API, exclusively for automation tasks. And then inside of the inside of the texture inspector, we'll do something else. So here's what I think we're going to do. First, we're going to read the contents of the file again. We did this once already up here when we were parsing out up here when we were parsing out the data. And we have the load texture asset data handler too, which is making this a lot simpler. But we discarded it because we didn't need to keep it in memory once we understood what to put inside of the fields, which fields were mixed, which ones weren't. So what we'll do is we'll read the contents of the file again. Then we will edit the changed contents of the file, or edit the contents of the file with the non-mixed data. So if the field's mixed flag is set to true, then we will skip editing it. Otherwise, we will edit it. That'll give us the merged changes. And then we will write the contents out to file. That's the solution. Hang on. I can actually utilize this API after all inside of the inspector. What this means is that we will construct a texture asset data on the stack from the file. We'll make changes to each one as they come in, and then we will write those out to file again using just by passing it into this function. So yeah, we're good. We're on the right track. So this code here will be pretty simple. We'll just write it out, and then once we're done with that, we get the save function working, and then all of a sudden everything will work. So first we need to read the contents of the file. So we'll need a structure to put it in. That's the texture asset data. I'll just call it data equals, no, it's assigned a different way. We use the load texture asset data function. We will pass in the path, which is called file in this iterator, every file and select files. And then we will pass the address of the data structure. So that populates this. However, we do need to do a validity check. So we'll say if it works, then we will do steps 2 and 3. Else nothing, because if it doesn't load, then we just step over to the next file. Though I will want to put a warning in here, so I'll do EP warn. Actually, EP error. And we'll say texture inspector on apply. Unable to open or unable to load file. Pass the path in from the loop. Okay, cool. And then in here we will make the edits that we need. For this is basically just a bunch of if statements using the values of these booleans. Copy you and paste you. Oops. And so for this, we'll say if the type is not mixed, then we will do the edits. So if the type's not mixed, it'll be field data dot these values, right? Field data at 0 dot these values. And we'll assign those values to data dot the same values of the same name. Data dot type, field data type. Yeah, okay. And if it's mixed, then we will skip. So this actually will be really straightforward. We can just do the one line of statements here because it's still very readable while compact. That's it, actually. That's all of the data from the field copied over if it's not mixed. And now we just need to write it out, and that should be done with a save texture asset call. And we'll pass in the final path again, and we'll pass in the data object by reference. And that's that, actually. All of these are simple value assignments, so they're pretty fast. It's occurred to me though that paths might not be a very fast copy, and so we can do a really obvious optimization here, where we only do the copy if is mixed is false and hang on a moment. Yeah, if is mixed is false and the path wasn't mixed when it was loaded. So we'll use the revert value here. Because remember, the 0th element is the value that's edited in the field, and the revert is the first element. So if it's not mixed now, and it was mixed then. So it used to be mixed, no longer mixed, we will make the edit. Because if they weren't mixed to begin with, then we didn't make any changes to the paths field. No, that's not accurate. Because we can make changes to an unmixed field and it would still be, yeah. So I'll just copy it this way as well. Hey, hello and welcome. Coding went today pretty smoothly, actually. Not very many bugs. Yesterday was hectic. There were so many little annoying bugs that I kept stumbling into, but today was actually smooth sailing. I'm knocking on wood right now to make sure that I didn't just jinx myself. But yeah, we're very nearly done with the serialization. In fact, that's just the very last thing to do. That's here. So now we have to do the construction of the YAML data. Like I did earlier, I'm going to write it out to the out YAML first. And then confirm that it's working correctly before I say it. Oh, weird. We have that touch the wood saying touch the wood saying in French. Yeah, it's I don't know where it originated from, but knocking on wood. You do that to undo your faux pas when you tempt fate. When you tempt fate, you knock on wood. You throw salt over your shoulder, and then you step outside and turn around and spit. Not all in that order, but these are all things that I've heard that you're supposed to do. Yeah, so I'll do a quick little thing here. So this is the first time I've been using the Rapid YAML library, Yolan, and the first time I'm actually writing data out with it. And it's actually really easy to construct a YAML file with it. You make a tree, and then you just say, get the root node reference, and then you just go through each node and you assign what you want. I say I want the root node to be a map, then I want it to have these keys and these values. The paths keys can have a value that's a sequence. And then I get its node and I just start putting things in it. It's actually really, really easy. I think this is way shorter code too than I had for the YAML CPP serialization. So I think I'm there where I say I might want to say that I will enforce the use of this instead of YAML CPP. And this has an effect on game developers too, because game developers who want to extend the editor, who want to add new kinds of components, they'll need to interact with my YAML serializations. So they'll need to make use of the library as well. But yeah, I think it's going pretty well. So here's the basics. We got the tree, we got the map, and now we got to do the values. So we have a texture asset data structure containing the values that we want to put in. The root node will need to convert data.type to a string. Do I have that function? I've got string to text filter, string to bitmap mode, and all that. I don't think I have the inverse. I'll need to do that. Tree collection is one I'm not used to. I often use list, dictionary, map, queue, but tree rarely seen in text. Well, a tree is not strictly speaking a collection type. A tree is a organization, a structural organization. Maps use trees. Dictionaries use trees. And, lists are not trees. They are just linked lists. But if you're using a map, wait, what am I saying? I'm being tired. So a map is a node of a tree. Basically, if you allow your map's values to be other maps, then that's a tree. My garden uses tree too. Yep. So you know all about trees, yeah. Okay, so I've got some helper functions here that I've been using when parsing, where I convert the string name of a texture filter to the actual type of texture filter, and same thing for map modes, texture types, and so on. I am now in a situation where I need to do the inverse. I think I'm missing a helper function too, actually, now that I'm looking at it. How did I get the texture type? Okay, I do have a string to texture type. So there's oh, my eyes glossed right over it. So string to texture filter, map mode, texture type, QMap projection, yes. So I'm gonna reorder these a little bit. I'm gonna have like a canonical order for these properties. So you got the texture type, then you got the paths, then you got the min, mag, and what is it? Min filter, mag filter, min, map mode, wrap mode. We don't support wrap mode yet, but we will. So that's the min and mag filter, our texture filters. Then you get your map mode, and then you get your QMap projection, and that's it. So each of these we will need to do an inverse function. So I'll do one for each of these. Static std string, and this is going to be texture type to stir, which, as we all know, is short for string. Oops, I control F something and didn't mean to. All right, and then we will take, and this will just essentially boil down to a switch statement. However, this is a helper function. It's not something that you'll be using as a. It's a helper function for me. It's not something that's used by the game developers. So I think here I'm going to do a const char value as a return value, because these are going to be string literals I return, and there's no need to make that, to wrap that in an object. So we'll do a switch on the type, and except I spelled type wrong. still spelled it wrong. All right, and then we do texture type. Come on, where's my texture types? This is one thing that I wish I had, like something like Visual Assist for, to be able to do the auto-populate your case statements. That's a thing that you can do in Visual Studio and with Visual Assist and in Xcode, but you can't do it in VS Code. Wait, maybe there's an extension for that. I'm going to search for that real quick. All of these seem to be unrelated to, they're talking about like changing your capitalization or something. Whatever, I'll just do it myself. We'll go to the texture types, Control C, and then Control V, and then that, and we'll do case texture type is this thing, break. And the thing that we do before breaking is return the string name of the thing we copied. Like that. Then we'll do an EP assert no entry. Make sure that we don't have a default unhandled case. Get rid of the underscores in the types, and then we'll do an EP assert no entry. Make sure that we don't have a default unhandled case. Get rid of the underscores in the types. 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 Actually, hang on a moment. Yeah, 1D array, 2D array, and cube array, I'm going to do underscores in the middle, but not at the beginning. Okay, that's looking good. Alt Shift F to do nice clean formatting. And then it's on to the texture filters. Static, const char star, text filter to stir. Takes a texture filter type. And we'll do a very similar thing. We'll open up the thing. We just have nearest and linear in this case. Anisotropic support will come, so I'll go ahead and make a case for it. Switch on the filter. And we'll do case texture filter. Linear. And then nearest. And nearest should be first. Then anisotropic. But this will be commented out. I'll just do it for now. And then we'll say return the thing we just said. Comment this one out, and then we'll do a default dp assert no entry. That's interesting. This one didn't want a same line. That's weird. This is literally shorter than this line, but when I do Alt Shift F, it breaks this line. Is it the comment? Is that the problem? That's weird. The presence of this comment seems to be causing the thing to want to break the case statement on multiple lines. Okay, now it won't do it when I do Alt Shift break, so that was weird. I don't know what's up with playing format. But yeah, that's fine. Good. Move on to the next one. Static const char star mip map mode to stir, and this will be taking in the mip map mode, except for it's not capitalized like that. It's like capitalized like this, and we'll say mode, and then we will grab none nearest and linear, and we'll put that in here. So we'll do this. We'll do case, or yeah, do case mip map mode colon thing return thing break fixing the stuff, the spelling and whatever, and then this whole thing. I'll need the insert no entry, and then we'll wrap this whole thing in braces and make it a switch on the mode. Cool. On these lines, hey Jolo, welcome in. On these lines, it's occurred to me that I want to do a return on them as well. I'll do a default value down here, so the compiler doesn't complain at me. Null pointer. Wait, that's the one. This is the one. All right. Cool. Yep. Good. Yep. And then there's the cube map projection, and that's it. That's the last one. What you doing? I am doing serialization of text files. Very nearly done. Never mind, don't explain. what's this last one? Qmat projection. So this would be const char star Qmat projection to stir. I don't know what you're talking about anyways. Yep. Basically I'm just actually saving changes that you make to the textures in the editor to file, so it actually functions as an editor. And yes, I am having fun despite myself. Despite how much work this is, I'm having fun. How about you? Are you having a good time, having fun? I should call this projection. Like that. Doing fine, you guess? Yeah. Sometimes fine is alright, you know? Not every day has to be the bee's knees. So we'll do a switch on projection, and then we'll do case statements for all the kinds of projections there are. There's only... Wait. Why is there a none? There might be a reason why I have a none value. I can't quite remember. I guess in the case where it's having a failure to read the Qmat projection, I was returning none. I was treating it like a null value. And then when we're parsing out the projection in the first place, okay, I'm going to change this and get rid of the none value. I wanted to play some Brink Valorant today, but I ended up procrastinating, sitting in the lobby, waiting for someone. So I just didn't play at all. Playing solo kind of sucks. Yeah. That sucks, man. Waiting on friends to arrive is the worst. Everybody's had that experience where they're just like, you know, they're excited to meet a friend out at a restaurant or something like that, and then you're way early, or you're on time and they're way late. It's not fun. You never know what teammates you're gonna get. Yeah, matchmaking is a tough thing to get right. Probably because most people are hard to evaluate. Okay, so I'm gonna get rid of the none Qmat projection because it doesn't actually have a function. Or at least not a function that I want to continue using. So texture type also has none. That's weird. I'm gonna get rid of these and then see what breaks and then fix it. Bitmap mode does have a correct none option. So if you set bitmap mode to none, that means that you have no bitmaps. You're just using the one texture, and that's totally fine in a lot of cases. Like your skybox, you'll never bitmap it because you're not going to be, unless you're doing like weird focal changes all the time. You're probably just going to want to do the one layer. But nearest, linear, and anisotropic, you can't not have a texture filter. The closest thing to a none texture filter is nearest. You can't have a none texture type. You can't have a none Qmat projection. The none Qmat projection would be not using a Qmap or a cube array. The skill is alright most of the time. I just don't like the toxicity towards younger players like me. Toxicity towards younger players. That's interesting. In my time playing first-person shooters, it was oftentimes the younger folks who would be saying things about how they fucked my mother or something like that. You've been finding ageism from the older folks. That sucks, man. Sorry to hear that. The only funny kind of toxicity is the effects of alcohol. I think that if you're playing a game and somebody is just hateful and they're saying really awful things that are unwarranted, that ruins my time playing a game. Alright, so I've removed those elements. Stuff will break in here, but I'll move past it. So here, when I go to return none, I'm instead going to return... I'll return rectangular, because that's probably the most common projection type. But we'll worry about that later. I guess it goes both ways, but not everybody's toxic. It really depends on the type of toxicity, yeah. Played Paladins earlier. A guy's name was Cockbender. Yeah. Yeah, if a guy was named Cockbender, I wouldn't want to get in a tussle with him. I wouldn't want to find out why they call him Cockbender. Alright. And then same thing for texture type. I'll just default it to 2D. And then texture type doesn't need a nutcase. Okay, and then back to where we were. We're doing a case statement for cube map projections. Now we've only got these three. So I'll paste. I will do the little formatting thing I do where I do the multi-edits. This would be a case, cube map projection, split cube and rectangular, and then we will do return the, I wasn't expecting that. I'll figure that out in a minute. And then break. That was weird. Split. Oh, I had copied a fourth line. That's where the problem arose. If you don't make money doing code, you should be a humorist. Yeah. That's my fallback. If I wind up a starving programmer, I'll fall back on my very secure job of being a comedian. Okay. Okay. Cool. So now we've got split, cube, rectangular conversions. Perfect. So now we've got all the conversion functions we probably will need for the sake of writing out to the file. So first, let me quickly resolve some of these errors that I developed while doing this. Texture type. There's a good argument here for a good argument against assigning a texture type if there's a failure to load a texture type. I'll come back to that one. It might be in my best interest to put the none case in there and then use that as a null. However, in the case of projection, if data out projection equals cube not none, projection value is invalid and return false. I will move on. I've been thinking about this for days. Is your PFP a profile picture, the Samus ball thing? Yes, it's a morph ball. It's what it says on the tin. I wound up changing it when y'all pressured me into making a Discord. And I had to give it an icon, and I decided to give myself an icon as well. Basically, I was one of my friends was starting up his Twitch channel, and he plays games on there still. He's an affiliate. But like I was in his early days, I would play games with him, and one of the times we streamed streamed my first experience with I think it was Super Metroid, the first time I played the original Super Metroid. I guess there hasn't been another Super Metroid, but you know what I mean. The first time I played Super Metroid, and one of the things that I did all the time was I would just like no matter where I was going, is I would curl up into the morph ball, and I would just like travel everywhere as a morph ball and bomb everything. And I don't remember how the name came up, but I became known as Morph Ball Michael in that circle, and so that was my name on Twitch. And then I started doing coding things. Okay, what do we got here? Root node type. The types are node ref and texture type. Oh, this is the save texture asset section, right? So that's fine. You know what? I think I am going to immediately reverse my decision on the none options. I'm not going to call them none, but I will call them error or null. Or invalid. I'll do null. Well, null implies that null is a valid value, so I'll say error. How about that? None is not a valid option, but I do need a way to confirm that there's no problem with the texture type and the cube map projection, because if the texture type is not read correctly, then we don't necessarily know that it will bind to a sampler correctly, so we don't want to load it in that case. Well, have a nice day. Gotta go get my pizza and go to bed. Bye-bye. Yeah, see you later. Have a good pizza and then have a good bed. I'll see you later. Yeah, so these will be error types now. So heading back to textures.cpp, we will now, instead of doing if the type equals none, we'll say type equals error, and then we will say the error message that's invalid, and then we will return false. And we'll do the same thing for cube map projection. Okay, that's good. What's my favorite go-to foods? That's an interesting question, because it's not what is my favorite food. It's the thing it's my bread and butter food. My bread and butter food is not bread and butter. It is probably a good sandwich with like grilled chicken in it. I think that'd be my go-to meal. It's simple. I don't have to think too hard about it. Tastes good. I think it's underrated. Kind of like a BLT. You know, not BLTs so much. BLT's only meat is bacon. And I do enjoy bacon, but I'm now in my 30s, and I've lost the zeal for bacon that I had when I was a teenager and a 20-year-old. It kind of just winds up upsetting my stomach a little bit because it is very greasy. Even though the flavor is so good, and I'll use it in all kinds of dishes. I don't tend to eat bacon directly, so probably not BLTs. I'd probably use something that's a little more hearty, like chicken or turkey, or if I'm feeling racy, I'll use roast beef. And then I'll use like a mixed green or a spinach or something like that instead of lettuce. I think those are good. Yeah. How about you? What's your go-to meal? I'm not sure what these squiggles are about. expected an identifier. That is the identifier. Texture type. Did I misspell error? No, I didn't. Okay, I'll leave that for the moment. I think all of these are fine still. I'm just double checking them because I undid a lot of things. Wanted to make sure I didn't undo something. Normally it would be pizza or poutine, but I recently bought a box of good ramen from Amazon. Eat ramen daily. Yeah. Ramen's good. There was a time when I used to do like the cup of noodle ramen a lot, or top ramen. But it's not very nutritious, doesn't really fill me up, so I don't do too much of that anymore. Real ramen from like a ramen shop is amazing. But yeah, like the dried ramen noodles, I'm not a huge fan of it anymore. In fact, I'm not even a huge fan of doing spaghetti at home. When I'm at home and I'm cooking pasta, as often as I can, I try to get fresh pasta. I don't really have immediate access to that stuff here, where I live now in Walla Walla, Washington. But in Chicago, where I was living a year and a half ago, I would frequently go to either Whole Foods or Mariano's, is a kind of a upscale, trendy grocery store with lots of fresh things, and I would get like fresh tortellini and stuff like that, and make that kind of pasta. Chicken noodle, by the way, is very good with udon noodles. It's a strange thing to try, but I used to go to an Asian mart in Seattle for udon noodles, and it's great. It's chewy, far better than using the wide noodles for chicken noodle. I'm not sure what I'm missing, but I feel like I'm missing something, but whatever. I'll gloss over it and it'll probably reveal itself later on. Oh, error, hang on. Error is a macro. Define error equals 0. So I can't use error as the name. What is that defined in? Did it say WinGDI? Is that the WinGDI? Yeah, so I have to give this a different name. How about just error lowercase? That work? Yeah, let's do that. Okay. All right, good. All right, so that should be everything. So now that we've got the types figured out, and we are now able to do conversion into strings, what I'll do here is I'll come back to the save texture asset. We've got the root node is now a map, and then we just assign the keys. So the type is going to be data.type, and we're going to pass that into texture type to string, and that'll return the string literal, which will be assigned to the root node. Is that good? Can we do that, or do I have to do I have to wrap it somehow? I think I have to convert this into a C4 string. So, yeah, let's take a look at the type that it takes. Uparound types are node ref and yeah. So let's take a look at the node ref class. And it's public operators or public constructors. Operator, okay. So operator can take a node ref. It can take const node ref, null pointer, C substring. So I think it has to be a C substring type. And if I'm remembering right, there's a conversion helper for this. So it'll be YAML C substring or to C substring. Then I pass in the construct pointer. Because of a C++ limitation, substring cannot provide simultaneous overloads when constructing from a car in and a car. The latter will be chosen by the compiler. Okay, so we have to do. It's saying there that it's explaining why it can't implicitly convert from a const car star to a C substring. But a C substring type is essentially just a wrapper for a C string, so it's not. There's no problem converting this. So okay, I think we're on the right track now. So I would basically do the same thing here for these other types, except for instead of doing texture type to C string, I would be doing texture filter or filter to text filter to C string. That would be data dot min filter. Right, and that'll convert into the min filter string. We do the same thing for the mag filter, and then the mip map mode value will be mip map mode to string, and we pass in the mip map mode from the data structure. Perfect. And then inside of paths, we will add children, one for every string inside of data.paths. So we'll add the node. So we added the node up here as a sequence. We will get a reference to it, and then we will do a for loop for data or for const std string reference path in data.paths. For every string we're trying to write, we will do paths node.append child and pass in the path. Except for it has to be a C substring type. So we'll do YAML to C subster path. And I think there's an std string overload for this. Yeah, const std string reference, so we can just pass in path. Okay, so at this point we've serialized everything actually. So this, we had to wrap up some helper functions to convert the types into whatever, but the actual YAML writing code itself, it's so short and sweet. I really like this API. So now that we've got that, I'm not writing to the file yet. What I'm doing is I'm just emitting it into this string buffer and then logging it to the console so I can see what it's doing. But yeah, I think that's everything. I probably have broken something when I refactored or changed the types inside of the projection and the texture type enums, but if we broke something, the compiler will tell us what I broke and I can fix it. I'm getting really excited because the thing that I want to do after this is working is I want to start implementing the other texture types, which means that we can add like a skybox if we want. And that'll be kind of nice to have in the editor because it's kind of, you know, like working in a scene with an inky sea of black behind everything makes it a little hard for you to orient the camera. So just having, it doesn't even matter what image it is, just having a skybox will make that a lot easier to read. Okay, we got some problems. What are those? Okay. All right. So first problem, error, no member named none. Yeah. So there's a place where I'm using none still. In the cube map projection in content.cbp. So what do we got? Glow texture implementation. I'm just using none as the default for the implementation function. It doesn't really matter what I pass in because as a 2D texture type, it'll ignore this anyway. And we haven't even implemented it yet, but I will pick a equirectangular here. I'm going to pick equirectangular as the default projection for cube maps for a couple of reasons. The first is that most of the 360 textures that you find online are going to be equirectangular, and the second is that it's obviously one image that's 2D, and you don't have to think about how to format it very hard. What else do we got? Inspector.cbp, too few arguments to function call, single argument, selected files was not specified. Right, we changed the onApply to pass in the selected files, but I forgot to pass it. Right, selected files is a set of strings, onApply needs a const reference to a set of strings. That's good. And that was it. F7 again. And hopefully this will all be working. Good, F5. All right, so it's building. Let's take a look at the inspector. I'll grab an aptext file. All right, so the first thing I've noticed is that we have a 1D texture type instead of 2D, like I thought it would be. So I screwed up something in the deserializer. Let's go to load texture, or parse texture asset data. And then when we go to read the type, we invoke string to texture type. The string comes in as 1D, should be that. Do I just have it saying 1D in the files and it's just not been a problem until now? No, they do say 2D. So I screwed something up. I want to fix that first before I move on. So I'll set the breakpoint here, and then I'll change my selection and see what we get. So C substring type, variables optimized away and something or other, that's okay. It's coming in as just the character 2. No, it's not. This is an array, and I'm not seeing all the elements. Hang on a moment. That's all right. There we go. So the string coming in is 2D. Okay, and then it does return texture type 2D. So data out type is 2D. So what gives? Why is it? So if data out type equals cube or cube map array, I'm stepping through, carefully watching the watch window where I've added the data out type. Okay, it returns true. And then what? So the 0th element is populated, the first element is not. It's got a default value of 1D. I step over. Now they both say that they're 2D, both buffers, which is correct. And yet after all that, it picks the. Maybe the problem has to do with the combo box. Maybe that's the thing I'm missing. So in the texture inspector code then, on inspector GUI, field data. Oh yeah, that was it. So previously I had a none target inside of the enum field. I removed that. That was the 0th element. So now when I do the field as an integer, I don't have to subtract +1 anymore. There's probably another one for the projection box that I need to take care of. Wait, I don't have a projection box yet, so we're good. All right, so that was, yeah. That was worth taking the time to fix. All right, so now we test the serialization code finally. I select the, I still have a breakpoint set. Let me clear the breakpoint and continue. All right, back to the editor. So I select the asset. I change something. I can revert it if I want. I'm gonna change the type to cube. I'm gonna leave the path alone, and then I will set these values to something different. And then I will say apply. And now if I go to the debug console now, we're saving save texture asset to C textures text1.eptext. The type is cube. Paths is C textures text1.png. Min filter is linear, mag filter is linear, bitmap mode is nearest, and that looks properly formatted. So that's great. There's one problem though, and that's the absence of quotes in the path. I should wrap that in quotes, I believe. Do I already do that? I do. I already wrap these in quotes. So yeah, let's take a look at that. But once that's done, once we have quotes in the path, or do we even need that? Do we even need quotes in the path? What I'm thinking is that maybe the Rapid YAML library is really smart, and it will put quotes around the string if there are spaces in it. So I'm going to test that right now. I'm going to make a change to this and add a space, then I'll click apply. And then let's see what the emitter put in there. Nope, the emitter just put in the whole thing without quotes. So let me. It's probably not mission critical to have quotes around it because this is YAML. The whole rest of the line is dedicated to the string, but I think it would be appropriate to have quotes, at least stylistically, so that it's consistent. So let's go back to the texture inspector where we do the serialization. Actually, this would be the serialize function inside of textures.cpp. So we'll do save texture asset. And when we go to save the paths, for every string that we append, we do need to have quotes around it. So in here where we have the string reference, I'm just going to do the simple thing. And do a concatenation. And I think that flies. I think that we'll see. I'll compile it. If that fails to compile, then I'll do concatenation through a constructor. Okay, that compiled. Let's see if it works. That decidedly did not work. Okay. So apparently this adding this character plus this just read me data adjacent to the character literal. Can I do in quotes? Do an escape quote like that? And concatenate. So that didn't quite work, no. They put okay, that's interesting. So we do have single quotes around the whole thing, which is new. But the character that it tried to... The character that it tried to insert was not the quote. Okay, so I'm thinking then if I do this and there's a need for quotes, I think it will insert. It just didn't find the need when I was just doing spaces. So I guess the only problem would arise if there's an issue parsing. And I have a feeling that there won't be, but I'm going to test it anyway, because I'm still new to this library. I'm going to put a space inside of this path. It means it won't work if I try to run the scene, but when I go to load up the string into the inspector, I'm curious to know whether or not it ditches the quotes or the space or anything like that. Textures... Okay, so it's got the space, it's ditched the quotes. If I ditch the quotes then, and hit save, and then select the file again, it also still works just fine. So, you know what? I'm not going to fuss over it. I'm going to just not bother with quotes. Because if you put quotes around the thing yourself, Rapid YAML handles that for you. And everything working is more important to me than the style of a file that people don't normally read. Okay, so that's that then. We've got the construction of the YAML file working correctly. The only thing that we have left to do is to actually save it out. So here I was doing this emitters YAML to emit to a string. We're just going to want to do, I think I could do write. I have a save text file, is what I've got in my file system. So what I'll do, I'll pass in the path that we're currently saving. And then the this does accept a const string reference for the text. I think at some point in the future I'll want to be improving my save API and my read and write APIs. I know more about like UTF-8 and character encodings than I used to know when I wrote those APIs. But yeah, for now I'll just use it like this. We take and construct an std string from the tree, and this is probably not an inefficient operation because the output still has to be allocated no matter what form you take it in. And then I take and pass that to the save text file to the path. And I guess we'll have to do an error check here. We'll say if that equals file error code success, then we will return true. Actually, what I'll do is I'll just return this value, the results of this operation. So that's doesn't even need to be in parentheses. We just do it like that. So it'll save the text of the file. If it's successful, it'll return true. Otherwise, it'll return false. All right, moment of truth time. 4 hours and 40 minutes in. So textures, I got a texture selected. I'm gonna make a change to it. I'm gonna make this say texture 3 and click apply. And now if I go to look at the contents of that file, text1.aptext, it's much shorter. We have the type as 2D, the path is to texture 3, and we have now got a new nearest to none for the min, mag, and min, mem modes. So yeah, that's looking good. Now, yeah, moment of truth time. Let's try loading up the scene. Scenes, basic 2D scene, and we've got 2 Hollow Knights. Look at that. So what's happened here is that inside of the editor, we had selected the first texture, changed its path, clicked apply. That saved it to the file. And then the next time we loaded the scene that referenced that texture handle, and I'll reload the scene now, it referenced the new PNG. So this is, there's still quite a ways to go to make this super useful for the editing of these assets, but we got the basics down. We deserialized, well, I should test one more thing before I move on. I should test out the saving of mixed values. I'm going to edit text 1 and text 2 at the same time, click apply, and take a look at these files. So text 1 is now nearest linear none. That's correct. And if we take a look at text 2, it is now nearest linear none. And you'll notice that these still differ in their paths because the path was a mixed field and we skipped over those differences when we wrote the file. And if we load the scene again, those changes take effect. Now they're both blurry. That's great. I'm feeling really good about this. So yeah, we've got the ability to edit texture assets inside of the inspector. And more to the point, we have a system with which we can add support for new kinds of assets, and modify them inside of the editor, which will come in real handy later. I think before I move on to the next thing, I will spend a little bit more time implementing a slightly better inspector field, and then we'll probably want to be able to reload the textures without screwing up the texture references. So by that I mean, if I open up texture 1, let me revert to texture 1 if I can. This file wasn't open when we were making the change, so it didn't save the original file. So I'm making a real quick change to the file that I can reload from. Here we go. So the idea is that if we were to wait, did I open the scene? Oh, that's weird. I'm not able to drag and drop the scene file anymore. I'll have to figure out what that's about. Can I drag and drop texture files? I can't. Okay, drag and drop is broken. I'll have to figure that out. But the idea is that you have a scene loaded up with all your assets, and you're like, okay, I'm looking at it, and I realize that the filtering on this is wrong, and I just want to change it. I select the texture asset, and then I say, let's change this to nearest, please, on the magnification, and then I click apply. I want that to trigger not just saving to the file, but also trigger a reload of the texture so that in the editor it will reflect immediately. Whereas right now I still have to reload the scene to reflect that. So that's something that's probably not an interesting thing to do. I'll do that offline probably tonight or tomorrow. But after adding some of these nice to haves to the inspector, we're at a point where we can continue working on materials, because we have we have a system through which we can create a material inspector, and we have assets to pass in to sampler slots. So yeah, we're going to be doing some cool work with textures here soon. Thanks for joining me if you did. I'll be back in tomorrow, I think. Have a great night.